your attention. Hello. The conference host.
Hello. Hello, Mr.
Hello.
Suresh.
Yes, hello. Do you have the pre-recorded presentation of the first speaker?
No, we are waiting for that Osman Odegajal. He just responded in WhatsApp, so we are waiting for that person. So please kindly
Okay, right.
wait.
That's fine. That's fine. Okay, I can.
Yeah,
No
just
problem.
now only
Right.
he responded. So we are waiting for him.
Hello.
Hello.
Okay. Okay, right.
Mr. Suresh.
Hello, am I audible? Can you hear me?
I can hear you, Ismail.
What about others? What about others? Kindly let me know. Can you hear me? Hello, can you hear me? Okay. I think all of you can hear me. Kindly let me know if someone cannot hear me, please. Hello. 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 What about the conference organizer? Can you hear me? Hello.
Yes, yes,
The conference organizer. Kindly let me know. Can you hear me or not?
yeah, I'm hearing you.
Sorry.
Yes,
Can you hear me?
yes, your voice is audible to me.
Can you hear me?
Yes,
Hello.
yes, your voice is audible to me. You can go ahead.
All right. Okay. That's fine. Okay. Now I am going to start the event. Okay. Now I think the time is okay to start the event. Okay. Dear all, a very good morning and a warm welcome to all keynote speakers, delegates, and all our well wishers for this grand event. Okay, I am Suresh Shalvihara from University of Peradeniya, Sri Lanka. I am the moderator at this virtual session on behalf of this Scholars Conference. It gives me immense pleasure to cordially invite you to the hybrid event of Scholars fourth edition of International Conference on Catalysis and Chemical Engineering, CATCHEM 2023. Uh, I thank you all for finding time in your busy schedule to be here today. Okay, today marks the major activity in the brief existence of this Scholars Conference, a moment where we are interacting, sharing experiences, reflecting on various areas. This virtual session is a remarkable event which brings together professors, researchers, and students in making the virtual session is a perfect platform to share experiences, foster collaborations across industry and academia, and also evaluate emerging technologies across the globe. Okay, first of all, I would like to give you some introductions regarding the manners and behaviors during this conference. Actually, these are the tips for meeting attendees. Okay, first of all, mute your microphones. That means you can keep in mute your microphones until you are getting access to talk. Right, the conference host will give you the access when uh, you are having a time to speak. Right. Okay. Actually, we are expecting to keep background noise to minimize and make sure you mute your microphones when you are not speaking. Right. Thank you for adhering that point. Okay. Then be mindful background noise. Okay. When your microphone is not muted, it is and also please avoid activities that could create additional noise as shuffling papers, and so on, right? And also using pens and hitting by using pens, those are prohibited during this conference, and during other session it will make some disturbance for others, right? Therefore, please follow these ethics. And also, positioning of your camera, please use a web camera, but sure it is in a stable position and focus at your eye level. If possible, doing so help create a more direct sense of engagement with other participant. And also, limit distractions. You can make it easier to focus on the meeting by turning off notifications, closing or minimizing running other apps. Even you are using a mobile phone, you can follow these instructions. And also mute other apps in your smartphone, and also avoid multitasking. That means you are allowed to work with this conference. You are not allowed to do other works while joining with this conference. Actually, please follow this seeking. It will help us to continue a successful conference ahead. And also, you have to follow these guidelines when you are using paper materials in advance. If you will be sharing content during the meeting, make sure you have the file and all other links ready to go before the meeting begins, right? Okay, these are the major introductions and major tips I have to give you at the beginning. Okay, now I will briefly introduce the following keynote speakers, right? Okay. Mm, uh, the first fellow is Professor Osman Adigusel from Firat University, Turkey. Okay, I now the takes immense pleasure to invite Professor Osman Adigusel, Firat University, Turkey, to deliver his keynote speech. His topic is the shape, reversibility, and structural reactions in shape memory alloys. Okay, Dr. Firat Adigusel, are you ready to continue your speech right now? Dr. Firat, hello. Dr. Firat, hello. Okay, until Dr. Firat is joining with this conference, I will introduce about the other keynote speakers in brief. Okay. In next, Dr. Haibo Jet from Texas Technical University, United States, America, and his keynote speaker will be based on the digital functionalization via transition metal catalysis. This is his speech title. And also, the next speaker will be the EKT Sivakumar from Anna University, India. He is going to talk about the green synthesis of cellulose, zirconium oxide, nanocomposite, assessment of photocatalysis activities. Okay. Then the next speaker will be the Oleg B. Grado. He will speak about the microfluid polarographic catalymetry. Dr. Oleg B. Gradov is coming from Semenov Institute of Chemical Physical, RAS, Russia. After the refreshment break, Dr. Anatoly Startev will continue his speech. He is coming from GK Bosco Institute of Catalysis in Russia. Okay, his speech title will be the H2S, a new insight into its role in human activity. Okay. Yes. Now I think Dr. Firat is available to continue his speech. Now I would like to introduce Dr. Firat. If he's ready to continue his speech, you can continue it ahead. Dr. Firat, are you available now? All right. Okay. I think there is a small change in this schedule. Right. Okay. I think Dr. EKT Sivakumar from Anna University, India, is ready to continue his speech. I think his speech is based upon the green synthesis of cellulose, zirconium oxide, nanocomposite, assessment of photocatalytic activities. Okay, Dr. Sivakumar, now you can continue your speech if you are available. Now it's okay. Are you available now?
Actually, I am planning 4 o'clock.
4 o'clock.
Yeah.
All right. Okay. Okay.
As
If
per
you have
the schedule I am planning, that time I will join.
All right. Okay. That's okay. Right. No problem. Right. Okay. Okay. Then I will resume the introduction session again. Okay. I think Dr. Rehana. Okay. Wait. I think Dr. Rehana Asgar from Mirpur University of Science and Technology, Pakistan, also participating in this conference and going to continue enhanced thermostability and enzymatic activity of selenium variants from thermobifida. Okay. Hello, Dr. Haiboge. Hello, Dr. Haiboge.
Hi.
Okay. Are you ready to continue your speech right now?
Yeah, sure.
Right. Okay. Very good. Okay. There is a small change in our schedule. We would like to warmly welcome Dr. Haiboge from Texas Technical University in United States, America. He is going to deliver his speech on digital functionalizational via transition metal catalysis. Dr. Haiboge, now it's your time. You can continue your speech ahead. The screen is yours. Thank you.
Okay. So can you see the screen?
Yes, I can see. Yes,
okay,
well shared. Okay, continue your speech.
All right, thanks for the kind of introduction. Okay, so it is my great pleasure to share with our research results. Okay, so basically a synthetic medicinal and organic chemistry research group. We are interested in developing, let's say, new organic reactions and try to apply them into synthesis of a drug molecule, drug-like molecules, and also organic materials. All right. Over the past 10 years-ish, so our main focus for the methodology part is the CH bond functionalization. All right, so because theoretically, CH bond functionalization is the most efficient way to build up, let's say, organic molecules. In fact, actually, CH activation of methane has been used in industry to make a DCM in, I think, around 25%, 30% of DCM was made in this way. Okay. But if we look about, let's say, a molecule with multiple CH bonds, the situation gets complicated, all right? So because it will be relatively hard to reach, let's say, a selective CH bond functionalization in this case, all right? So then in 2001, a group from Columbia University developed, let's say, a different strategy, which is called a cysteine group assisted CH activation. In this case, all right, so if you have something like a cysteine group on a atom, typically heteroatom, oxygen or nitrogen, all right, so then with a transition matter, so you can selectively break the CH bond shown on the right to make these 5-membrane intermediate. So from there, you can convert CM bond into different, let's say, X bonds. Let's say that. So this is a great method, but it has some disadvantage. So which is the cysteine groups are required in the process. All right. So once you're done, so then you have to remove it. So overall, the efficiency is low. So because of this, starting from 2014, 15-ish, we try to, let's say, do this chemistry by using common functional groups such as aldehydes, ketones, amines. All right, so then let's see that amine. Our first study on the amines. Okay, so remote functionalization of amines. The driving force is, one is methodology development, and second one is application, all right, because we are interested in the application side, all right. So it looks like if we could make, let's say, selective CH activation on the gamma position, we should be able to make, let's say, different drug molecules in very efficient way. If we look at the CH activation of amine on the gamma position, by that time there was a report, but it wasn't, let's say, gamma selective is terminal selective. Okay, so then, but people realize this method extremely important. So over the past, 10 years each before that, so many groups have been working in the field to, let's say, reach gamma selective CH activation by using a bidentate or monodentate directing strategy. All right, anyway, so a directing group or an assisting group is required in either case, all right. So, but anyway, so with this help, so the CH activation could happen in a very efficient way. All right, so then we thought, okay, so can we use amine directly for this reaction? All right, our strategy is called transient ligand enable CH activation. In this case, so we imagine if we have a ligand which can bind to substrate in reversible manner, so this ligand may control the site-selective CH activation. So then we can get this reaction to go. For this specific, let's say, substrate, we thought, okay, so aldehyde or carbonyl group could be a good starting point because we know imine formation is reversible. All right, so if we have a second heteroatom, so we can have bidentate ligand, which can coordinate to the matter, so directing the CH activation. So from there, the chemistry should be straightforward. All right. So we have this idea from, let's say, literature support in 1997. Jones group reported the CH activation of aldehyde in the presence of this aminopyridine as a transient ligand. All right, so they believed the imine formation is the key in the process, followed by oxidative addition. So then you can do the chemistry. In 2014, Guangbin Dong from Chicago reported, by that time was Austin, reported alpha alkylation of cyclic ketone by using these as a catalytic ligand. All right, so then how about, let's say, palladium on the remote position? Okay, so then we thought, okay, so within this strategy, at least we had a chance. So then we tried this reaction with these two specific substrate. The reaction worked in decent yield after actually screening lots of different ligands. All right, so we found actually glyoxylic acid worked pretty well, providing desired product in 80% yield with the addition of a 4 equivalent of water. So then substrate scope study, we found actually for the aeroiodides, we didn't observe any severe limitation, but for these amines, okay, so the alpha position or beta position must be fully substituted carbon. Otherwise, the reaction will be very inefficient. Okay. So then next, reaction mechanism. All right. So we believe the reaction starts from imine formation, followed by pollination onto the palladium. So then CH activation will happen to form the bicyclic intermediate. From there, oxidative addition with either benzene followed by reductive elimination will generate this intermediate. So then we have ligand dissociation followed by imine dissociation, which will provide the desired product and the catalyst back. All right, so you only need to load 20% of these glyoxylic acid. To try to provide some evidence for the reaction mechanism, we try to isolate these key intermediate. Luckily, with the addition of a protein as an external ligand, so we could get the structure which is confirmed by X-ray. Once we subject these onto our standard conditions, we could get a desired product in similar yield. All right, so which kind of suggests these should be the intermediate in the process. Okay, so then we carried out let's say gram scale synthesis. It worked just fine. We also synthesized a drug molecule called a fingerling in 3 steps from this commercially available starting material with 2 columns. So this is the most efficient, let's say, way to synthesize this drug molecule. All right, as said earlier, so we had a problem for these substrate scopes. Alpha or beta carbon must be fully substituted. And later we thought that we have to solve this issue in order to get the industry people to use our method. All right, so then we tried it by replacing this ligand with this one. Then we could get this reaction to go to partially solve the problem. Okay, alpha position, we can functionalize alpha amino acid in this case. Later, we found actually with these salicylaldehyde, we could completely solve the problem. Linear carbon secondary sp3 CH bonds are all fine in this case. All right, pretty much at the same time. So 3 different groups reported, let's say, the similar process by using different types of ligands. All right, which is general. Okay, so then once we had this reaction, process completed, all right, so then industry people from Eli Lilly asked us if you can synthesize 4 membrane azide derivatives, because this moiety is very common in drug molecules. And we thought, okay, so why don't we try it? And we use this alpha amino acid as a starting material. With this ligand, we could get this reaction to go in modular yield, along with these as the byproduct. Okay, interestingly, we found actually if we subject these byproduct onto our standard conditions, this thing could be converted to the desired product. All right, so based on this, we propose a reaction mechanism, the imine formation followed by CH activation. All right, so we're going to generate these key intermediate. From there, oxidation followed by reductive elimination, we generated the OAC on this gamma position. So then from there, so we have a ligand dissociation followed by imine dissociation. We're going to generate the product B. So intramolecular cyclization, we're generating product A. All right. So then, so we know we can functionalize gamma position of the mean. How about the delta position, remote position? Actually, this process is extremely challenging because the 5-member ring planar cycle formation is always favorable compared with 6. Typically, if you want to make 6-member ring planar cycle, you have to block these positions. Right. So actually, we reported one example in 2021. Okay, so then we thought, okay, so can we play with the ligand to achieve the selective CH functionation on the delta position? So luckily with this as an external ligand, we could get this reaction to go. At this moment, efficiency is not that high, but at least we have shown that actually we could reach kind of, let's say, the delta selective CH activation in better, let's say, yield compared with gamma. All right, so then pretty much at the same time, we were also working on the CH activation of aldehyde. The idea is simple because if we could functionalize the mean, we should be able to functionalize the carbonyl group on the beta position. All right, so if we look at the aldehyde at that time, there were 2 different strategies. One is oxidation, followed by conjugated addition. One example, low yield. And the second method is Macmillan's chemistry. So photocatalyzed the CH activation on the beta position of aldehyde. All right. So through, let's say, radical process. Then we thought, okay, so if we could make this reaction, could provide a complementary method. All right, so then we tried this reaction. We found actually by using beta alanine as a ligand, we could get this reaction to go in decent yield, I'll say that. So again, so for the arrow iodides, we didn't observe any severe, let's say, substrate scope limitation. But for this aldehyde, we found actually only terminal position, terminal sp3 CH bond worked well in our case. Okay, as you can see that in lineal, these 2 lineal substrates are not good at, let's say, partners in this case. All right, so reaction mechanism should be similar. All right, so we have imine formation followed by CH activation. We generate a regular process, we're going to get the product. So we try to synthesize this molecule or this intermediate. All right, so we found actually we could isolate these, but we don't have X-ray. We have NMOS to confirm it is, let's say, this compound anyway. So also this intermediate could be converted to the desired product on our standard conditions. All right, so it demonstrates or it suggests this should be the intermediate in this process again. All right, so originally, as I said, we had a problem, so we couldn't functionalize, let's say, linear aldehydes, and then later, okay, so we played around with different, let's say, I would say external ligands. Eventually, we found actually with the combination of these ligand and these as a trans-interacting group, so we could get this reaction to go in reasonable yields. All right, so this reaction actually tolerates, let's say, natural products, shown here. In collaboration with Professor Yan Fengdang at Tianjin University, so we carried out, let's say, a calculation study. We know that actually, so the we proposed the 5-member information later cycle should be the energy, activation energy should be lower than 6-member. According to calculation, actually the CH activation is a rate determining state. So the 5-member planar cycle, let's say, activation energy is lower than 6-member, about, let's say, 4.3 kcal per mole. That explains why we get, let's say, these beta CH activation over the gamma CH activation. All right. Also, kind of, let's say, explains why 6-member platelet cycle formation is hard compared with, let's say, 5-membrane. But the question is, can we make the 6-membrane platelet cycle? In this case, we will be able to functionalize the gamma position of the aldehyde. Okay, so then we thought, okay, so why don't we play with steric effect? All right, so we know, okay, so if we have the 5-membrane formation here, even we have it, okay, so next step could be challenging due to the steric effect. Although on the other hand, so this thing might not be, let's say, favorable compared with the 5-membrane, but the next step will be more favorable. So, and we tried it, it worked. Okay, so we can functionalize the gamma position in reasonable yields. All right, so then how about the ketones? If aldehydes work, ketone should work. Actually, ketone worked pretty well. In this case, the good thing is actually with ketone, so we can carry out, let's say, initial selective process because the ketone products are more stable than aldehyde product. All right. Okay. Now I'm going to share with you, let's say, our recent work on sequential CH activation. All right. So originally, let's say, our collaborator, this collaborator work with Professor Mahdi at IIT Bombay. So originally, Mahdi's group developed, let's say, the gamma CH activation of acid by blocking the beta position. All right, so then based on this, so we designed that actually, so can we functionalize the ring and methylene sp3 CH bond over the methyl group? So from here, we noticed actually, we realized that methyl CH activation should be more favorable compared with methylene. But the next step, CO bond formation, reductive elimination should be challenging compared with these. All right, so compared with beta hydrogen elimination. So in other words, we thought we may be able to overcome these, okay, by favoring the formation of these alkene. So then from alkene, we can do oxypalidation to get the cyclic system, or we can even do sp2CH activation followed by oxypalidation to get these bicyclic system. All right, so with these ideal, so in mind, so then we carried out, let's say, the experiment studies we found actually, so we could get this reaction go. So this reaction favor the cis formation. So in this case, okay, it tolerates, let's say, from 5 to 15 sized rings. All right. Okay, so then we, according to mechanism, we have CH activation followed by beta hydrogen elimination. So then we have oxypalidation followed by reductive elimination. We get the desired product. All right. We calculated, we collaborated with Shenlong Zhang from Singapore for the magnetic studies. Actually, we found that these CH activation is a trans. All right. So I don't want to go too much the details. All right, so in order to demonstrate the synthetic application, we synthesize a couple intermediates toward some, let's say, natural products. So they are more efficient compared with the current reported process. Okay, so then next, can we do the sequential CH operation? All right, so by sp2CH activation. So I would say that we could get this reaction to go with conjugated olefins or these allylic alcohols. Okay, so the yields were pretty good. Okay, so with good diester selectivities. All right, so to summarize my talk, so basically we have been focused on the sp3CH activation over the past 10 years. So we are able to functionalize, let's say, these remote position of aldehydes and amines. So we are now working on the cyclic amines and alcohols. All right, so it looks like if we could get this reaction to go, so we have ways to functionalize different types of, let's say, the molecules. All right. So eventually, I would like to thank, let's say, my postdocs who were or are working on the projects, and a couple graduate students also involved in this process. So I would like to thank our collaborators, Professor Deb Marty from IIT Bombay, Shinlong Zhang from Singapore, and Yonghong Dang and Tianjin University. Okay, also like to thank, let's say, NSF, Welch, and support from universities, Texas and Texas Tech and IUPUI. All right, eventually, I would like to thank you for your attention. Thanks. I would like to answer any questions if you guys have.
Thank you very much, Dr.
Thanks.
for the valuable presentation.
Thanks.
Yeah, thank you, Mr. Haibodi. Now
Okay.
I introduce Mr. Osman Argajal from Firat University, Turkey, and he will deliver her keynote speaker on shape reversibility and structural reactions in shape memory alloys. Yes,
Thank you very much.
Continue.
Can I share PPT of my talk? Good morning, good afternoon, and good evening, distinguished scholars, colleagues, participants, speakers, and the moderators at the different locations on the globe of the world. Let me inform you that I had an on-site conference today in Istanbul, Turkey. I joined that conference physically, and I returned back to Ankara, and therefore I couldn't join the yesterday's sessions of the conference. First of all, I would like to introduce my sincere thanks to the conference committee, conference management, and conference company to provide me a facility to deliver my talk at this important conference. Let me inform you that this is a multidisciplinary conference. I am sure you agree with me that every scientist is not familiar with every subject of the science. Therefore, at the beginning of my talk, I will introduce the basic terms and definitions related to the shape memory effect, superelasticity, and shape reversibility in shape memory alloys. After that, I will introduce the experimental result performed on two couple-based shape memory alloys. As you can see, the title of my presentation is based on material science, and title is Shape Reversibility and Structural Reactions in Shape Memory Alloys. Shape memory alloys are thermoresponsive materials and exhibit a peculiar property called shape memory effect. This behavior is initiated with thermomechanical treatments on cooling and deformation, and performed thermally on heating and cooling, with the shape of the material cycle between original and deformed shapes in reversible way, and this behavior can be called thermal memory or thermoelasticity. This is plastic deformation due to the soft character of the material in the low temperature condition. Deformation energy is stored in the material and released on heating by recovering the original shape. These alloys exhibit another property called superelasticity, which is performed with mechanically stressing and releasing the material in elasticity limit at a constant temperature in the parent phase region, and this behavior can be called mechanical memory too. These are the processing or shape memory effect and superelasticity. As I stated, for the shape memory effect, materials are deformed in the low temperature condition, and upon releasing, material keeps the deformed shape due to the plastic deformation. After that, on heating, record the original shape and shape of the material cycle between deformed and original shape on cooling and heating in reversible way. For the superelasticity, materials are stressed in elasticity limit in the parent phase region, and upon releasing, recover the original shape by exhibiting elastic material behavior. Shape memory effect is result of the structural reactions, thermal and stress-induced magnetic transformation, and evaluated by the structural change in atomic scale and the crystallographic level. Shape memory effect is performed thermally in a temperature interval, depending on the forward austenite martensite and reverse martensite austenite transformation on cooling and heating, following the first cooling and deformation processes. Superelasticity is also a result of the stress-induced magnetic transformation and performed with mechanical stressing and releasing in elasticity limit at a constant temperature in the parent phase region. This is the temperature hysteresis shape memory alloys on cooling and heating. As I stated, thermal induced magnetic transformations occur on cooling and start at MS temperature and completed at MF temperatures. After that, on heating, reverse austenitic transformations start at AS temperature and completed at AF temperature. MS is Martensite start and MF is Martensite finish temperatures. Also, AS is austenite start and AF is austenite finish temperatures. These are the stress strain characteristics in shape memory effect and superelasticity. As I stated, for the shape memory effect, materials are deformed in the low temperature condition, and stress-induced magnetic transformations occur at the plateau level for thermoelasticity and superelasticity. As you can see, early stage of the deformation exhibit elastic material behavior. Also, as you can see, stressing and releasing paths are different for superelasticity, and this hysteresis loss refers to the energy dissipation. Shape memory behavior is evaluated by the macrostructural change in atomic scale caused by the internal stresses, and shape change occurs in the bulk level. Shape memory effect is governed by thermal and stress-induced magnetic transformations. Thermal-induced magnetic transformations occur with the cooperative movements of atoms by means of lattice invariances in one monotype direction on the one monotype planes of the austenitic matrix, and ordered parenthesis structure turn into the twin magnetic structures. Also, twin magnetic structures turn into the determined magnetic structures by means of stress-induced magnetic transformation by stressing the material in the low temperature magnetic condition. Superelasticity is also governed by the stress-induced magnetic transformation, and ordered parenthesis structure turn into the determined magnetic structures with stressing the material in the parent region. This is the schematic or shape memory cycle in the crystallographic level. Let me inform you that shape memory effect and superelasticity is observed in the beta phase region of the materials, and ordered parenthesis structure is essential for the quality of shape memory effect and superelasticity. First step is cooling for shape memory effect. On cooling, ordered parenthese structures turn into the twin martensitic structures by means of thermal induced martensitic transformation. After that, with the deformation in the low temperature condition, twin martensitic structures turn into the detriment martensitic structures by means of stress-induced martensitic transformation. Following these treatments on cooling, on heating, detriment martensitic structures turn into the ordered parenthese structure and crystal structure of material cycles between detriment martensitic structures and ordered parenthese structures on cooling and heating in reversible way. Let me inform you that detriment martensitic structures occur with mechanically stressing material in the first step, but in this cycle, on cooling and heating cycle, detriment martensitic structures occurs thermally on heating instead of deformation. This is also schematic of superelasticity. As I stated, for the superelasticity, materials are stressed in elasticity limit in the parenthetical region and ordered parenthetical structure turn into the detriment martensitic structure by means of stress-induced martensitic transformation. After releasing detriment martensitic structures turn into the ordered parenthetical structures by means of reverse astatic transformation. It is important that this cycle is completely mechanical for superelasticity, and the same cycle for shape memory effect is thermally. As I stated, superelasticity is also linked with stress-induced martensitic transformation, which is induced by applying only mechanical stress, and with the stress, parent austenic phase structures turn into the completely detriment martensitic structure, as in the deformation step of the shape memory effect, and detriment martensitic structures turn into the parent phase structure upon releasing. Also, crystal structure of the material cycles between detriment martensitic structures and ordered parent phase structures on stressing and releasing. It is important that stress strain curve exhibit nonlinear behavior, and stressing and releasing paths are different, and hysteresis lobes refers to the energy dissipation. This is the stressing and releasing path for superelasticity in stress strain diagram. As you can see, stressing and releasing paths are different. Also, this diagram exhibits nonlinear behavior, and this hysteresis lobes refers to the energy dissipation. It is important that even if stressing is very quick, releasing is very slow, and with these properties, these alloys mainly used in building industry against the seismic effects. Martensitic transformation is a first order solid-state phase transition and occurs in a few steps with the cooperative movements of atoms in displacement manner. Therefore, this transition have diffusionless character, and product martensitic phase inherits the order of parent austenitic phase. Martensitic transformations mainly occur into basic steps in the beta phase region of the materials. These are Bain distortion and lattice invariant share. These are the basic beta phase structures in the beta phase region of the materials. First figure represents the ordinary body-centered cubic structures. Second figure represents the cesium chloride type superlattice structures. Third figure represents the DO3 type superlattice structures mainly observed in the ternary couple shape memory alders. Also, last figure represents the L21 type crystal structures. Beyin distortion is mainly effective internal kapı yapmaları alırsan consists of an expansion of 26% 001 type axis called beyin axis and a compression of 11% in the 1 type direction perpendicular to the beyin axis. There are three beyin axes. These are cube axis 100, 010, 001 and BCC base unit cell turn into the body-centered tetragonal structure as three variants with different orientations. Lattice invariances occur as Martensit variant on one monotype planes of the austenite matrix, which is basal plane of the martensite. Also, dashes occurs into opposite direction, one monotype direction on the one monotype planes of the material structures. One monoplanes family represents 6 certain planes and totally 24 Martensit variants occur with the lattice invariances. These planes are listed as follows: 110, minus 110, 101, minus 101, 011, and 01 minus 1. Lattice invariance and lattice twinning is not uniform in coupled base yapmaları aldıysan dashes cause to the formation of layer structures. One monotype planes of the parenthase, this is basal plane, turn into the unusual layer structure which consists of an array of closed bucket planes with complicated stacking sequences called as 3R, 9R, or 18R martensitic structures depending on the stacking sequences on the closed bucket planes of the ordered lattice. The periodicity and therefore the unit cell is completed through 18 layers in direction that in 18R martensitic structures internal kapı ve yapmaları alır. This is the formation of layer structures with lattice invariances. First figure represents the stacking of one monotype planes of two parentheses with the lattice invariances. The stackings turn into the layer structure with stacking sequences ABC, BCA, CAB, A and other for DO3 type structures of the parentheses and 18R martensitic structures internal kapı ve base yapmaları alır. These are the basic terms and definitions related to the Chapman-Murray effect and superelasticity. As you can see, experimental studies were performed on two copper-based Chapman-Murray alloys. These are copper zinc aluminum and copper aluminum mangan alloys. You can see alloy compositions and this composition were selected in the beta phase region of the material. As you can see, martensit start and martensit finish temperatures are over the room temperature for both of the alloy samples, and both of the alloy samples are in the martensitic state at the room temperature. Specimens obtained from these alloys were solution treated for homogenization in the beta phase field as following, then quenched in ice grain and aged at room temperatures. These temperatures are 830 and 700 degrees for copper zinc aluminum and copper aluminum mangan alloys, and these temperatures were selected in the beta phase region of the materials. Powder specimens for X-ray examination were prepared by filling the alloys, and the specimens were sealed in evacuated quartz tube and given the beta phase homogenization treatments in order to release the strain effect. These temperatures are also the same, and homogenization time were selected as 15 minutes for both of the alloy samples. Powder diffractorams were obtained from the specimen at the different stage of aging in a long time interval. Sorry. This is an X-ray diffractoram taken from copper zinc aluminum alloy samples after long-term aging at room temperature for about 15 years after quenching. As you can see, peak intensities and peak characteristics are different, and this diffractoram exhibits superlattice reflection. Let me inform you that these plane pairs are important for ternary couple bishop numero alloys. These are 122, 202, 128, 208, 110, 210, and others. This is also another X-ray diffractoram taken from copper aluminum mangan alloy samples after long-term aging at room temperature for about 15 years after quenching. As you can see, this diffractoram also exhibits the same characteristic with as plane pairs. As I stated, a series of X-ray diffractorams have been taken from both of the alloy samples in a long time interval, and some change have been observed in the diffraction angles, peak intensities, and peak characteristics with age and duration. In particular, some of the successive peak space have shifted toward each other, and these peaks provide the following relation between Miller indices for 18R martensitic structures in ternary couple bishop numero alloys. This plane pair can be listed as follows, as I stated on the diffractorams for 18R martensitic structures in ternary couple bishop numero alloys: 122, 202, 128, 208, 110, 210, 040, 320, and others. At the long-term investigation, it is observed that these peaks pair come close to each other with age and duration, and this change reveals the changes in the crystal structure of the material. Also, this change refers to the rearrangement of atoms in disordered manner. The basal plane of the martensite is subjected to the hexagonal distortion with martensite formation, on which atom size have important effect. In case the atoms occupying the lattice sites have the same size, it is important, the basal plane of the martensite becomes regular hexagon. Otherwise, deviations occur from the hexagonal arrangement of the atoms in case atom size are different. In the disordered case, all of the lattice sites are occupied randomly, and atomic sizes can be taken approximately equal each other. In the ordered case, lattice sites are occupied regularly by certain atoms which have different atomic sizes, and basal plane of the martensite deviates from the regular hexagonal arrangement of the atoms due to the atom size differences. This is the basal plane of the martensite, 110 type plane, and this rectangular shape turns into the hexagonal shape with the martensitic transformation. In the disordered case, we don't know which atom occupies which lattice size, and we can take atomic sizes approximately equal each other, and hexagon becomes regular hexagon. In the ordered case, atomic distribution is regular, and neighbor atom size are different, and deviations occur from the hexagonal arrangement of the atoms due to the atom size differences. Second, experimental study is performed on transmission and scanning electron microscope by taking electron diffraction patterns and image of surface and interface of the material. You can see here is electron diffraction pattern from both of the alloy samples, and as you can see, electron diffraction patterns also exhibit super lattice reflection for both of the alloy samples. Conversion Chapman effect is evaluated by the structural change in microscopic scale by means of multi-slit transformations. The fundamental structure of the beta-type martensites are orthorhombic closed packet structures, which consist of an array of the closed packet planes in coupled Chapman alders. The beta-type martensites have the layer areas by the stacking sequences depending on the order in the parenthetical region. Coupled by ternary alders have duotary type superlattice structure in the parenthetical region, and the following stacking sequences occur with the multi-slit transformation. The sequences are AB, CB, CA, CA, BA, BC, BC, AC, and AB for 18R multi-slit structures in ternary coupled Chapman alders. Based on the obstinate martensite relation, the basal plane of 9R or 18R martensite originates from the 1 type planes of the parent phase on which lattice invariances occur in 1 type direction during the martensite transformation. These are the references. And thank you very much for your attention. If any colleague has questions, I will try to answer. I think there is no question, no comments. These are basic scientific statement. The way we see it, physics has too many gray areas already. Thanks again to listen my talk, and I wish you great success at the next part of the conference. Let me inform you that I have another conference half an hour later. Therefore, I have to leave the session, and I wish you great success at the next time of the sessions.
Yeah, thank you, Mr. Osman Adgajan. Thank you so much. Is there any questionnaires from audience? Okay, so we will continue with next speaker. Yes, I can call upon Mr. EKT Sivakumar, Anna University, India, and to deliver keynote speech on green synthesis of cellulose ZrO2 nanocomposite assessment of photocatalytic activity. Hello, Sivakumar.
Yeah, very good morning and good evening. Is it visible? Is it?
Yes, yes, it's visible.
Thank you very much. So I am very immense pleasure to join the Catalysis and Chemical Engineering CATCHEM in 2023. So today I just wish to discuss about the green synthesis of cellulose zirconium oxide nanocomposite for the antibacterial and photocatalytic activity. So my topic, I am the expertise in nanoscience and technology for more than 10 years here. So I am the industrial scientist. So based on the things, Actually, we are preparing the zirconium oxide nanoparticle. So this type of zirconium nanoparticle, whenever you know the nanoparticle, whenever you are using for the different application purpose. So there will be based on the size of the particle, there will be enhancing property in all sectors. So today, so even now I am in ceramic technology, this type of zirconium oxide widely used based on its property for the multiple application. So specifically, we are using for the dental and other application, bioceramic application. So now I special, innovative and very interesting application of zirconium nano composite with cellulose for the antibacterial and photocatalytic activity. So the main theme of my abstract. So by using the green synthesis, so yeah, everyone knows that green synthesis is very low cost and very effective way we can synthesize by using the various nano composites. Nowadays, most of the work based on the green synthesis, they are using the nanoparticle for the multiple application. So the present work, what we did it, the green synthesis of cellulose zirconium oxide nano composite, that is 1:1 ratio, and assess its antibacterial activity. So everyone knows this type of cellulose and zirconium oxide nano composite exhibit the very strong antibacterial activity against Salmonella, Typhimurium, and Bacillus cereus human pathogens. So this is very interesting finding in our side. Just today, I want to discuss some very interesting part of the some few points based on our application part of view. So cellulose zirconium nano composite exhibited most improved photocatalytic efficiency than the pure zirconium oxide nanoparticle. So we compared by using this type of composite, and after the preparation of the nanoparticle and you make it the composite material, and you can see the various advanced characterization techniques we use, and we find that there is a very interesting improvement in the photocatalytic efficiency property. So this type of green synthesis, it should be very effective and low cost, and this type of cellulose zirconium oxide nano composite, which was utilized as a versatile biomedical application. So under this type of conferences, just basic to the photocatalyst is defined the acceleration by presence of catalyst. So the catalyst does not change itself or being consumed in the chemical reaction. So the photocatalytic activity depends on the ability of different type of catalysts we can use it. Generally, nowadays, most of the metal oxide, such as zinc oxide, tungsten oxide, tin oxide, titanium oxide, iron oxide, are the most popular semiconductor explored as a photocatalytic materials. So our interesting, we make the photocatalytic nanoparticle. So generally nanoparticles have the photocatalytic properties that most of the nowadays the scientist and the engineer can speed up the reaction using the light sources. For photocatalytic nanoparticles are organic, maybe have the antibacterial properties and are considered cost effective. So that's why we also use this type of photocatalytic nanoparticles for our antibacterial and photocatalytic efficiency application purposes. So general, so nowadays, this type of photocatalytic nanoparticles, suppose if you are using the titanium oxide, we can use this type of for the removal of most of the organic pollutant. That is the things going on. So generally, these specific nanoparticles have the unique property acting as a catalyst and speeding up a reaction using light source, usually UV light. So the nanoparticle photocatalytic activity, we can observe the many volatile organic compounds. We can use the UV light, in presence of UV light, neutralize this compound and we can get it the CO2 and H2O. So most of the organic compounds photo-catalyzed by titanium oxide with UV light to produce the H2 and CO2. Similarly, organic compounds, many dyed material or whatever the things, we can use for the degradation process through hydroxylation. So that is the thing. So generally, the scheme of process of photocatalytic action in general. So you can see this type of UV titanium oxide for the multiple application. So the titanium oxide that you can use for the TI were to absorb UV light, strong, it acts as a strong oxidizing agent. So whenever any OH is produced, it can usually surrounded by the germ cells, destroy the germ cells and disintegrate the harmful substance and allergens. So we can get the H2 and CO2 released. So this is the common process of photocatalyst action will be taking place most of the things. So the next one is very yes. So I hope that you can see this is the, so our work, what we concentrated the nano particles preparation by using the green synthesis. So in our work, we can take the one of the marine algal species for this type of green synthesis. So generally nanoparticle synthesis through conventional techniques. So there are some of the toxic chemicals for capping and stabilizing agents for synthesis of materials will be taking place. But in case of green synthesis, using the plant extract microorganism, which were non-toxic and safe. So it offers natural capping agent and eco-friendly method for synthesis of nanoparticles. So this type of eco-friendly green synthesis nanoparticle using plant extract or microorganism which provides large scale production of metallic nanoparticles in a eco-friendly and cost-effective manner for medical application. So most of the work, whenever we are making nanoparticle for the multiple application of biomedical application. So this type of things, which you can use for the, generally we can select this type of green synthesis. So in our study also we take the green synthesis. So everyone knows the green nowadays, most of the green synthesis work is going on in the multiple application purpose since. So it has the huge advantages. So this type of green synthesis generally non-toxic and cost-effective, eco-friendly, and we can use this type of green synthesis for the natural capping agent. You can use the reducing agent for the various nanoparticle preparation. Generally, nanoparticles such as zinc oxide, titanium oxide, copper oxide, iron oxide, silver oxide, this type of things have been using industrial application and commercial products. So among them, so we concentrated on the zirconium oxide nanoparticle. So everyone knows this type of zirconium oxide nanoparticle is well-known material for antibacterial and wound healing is well established. So our aim is, so everyone, based on the material selection is very, very important. Any process, anything we want to execute, the selection of material, the availability of materials, based on the property of material, we can use the multiple application. So this type of selection of zirconium oxide, so everyone, it has the lot of ceramic application. There is advanced ceramic application based on its property, high strength, excellent resistant to corrosion and different chemicals. That's why this type of zirconium oxide nanoparticle, even nanocomposite, we can use for the ceramic application. So our aim is, so we want to make the zirconium oxide for the photocatalytic property. So addition to that, we can use this type of things for the biomedical application specifically for the antibacterial activity. So under the green synthesis using the plant extract. So our source is this type of zirconium oxide, any nanoparticle preparation, we can take the whatever the leaves, we can extract with the solvent or water, we can, based on that, we can mix with the whatever you are obtained, the plant extract, we can use, even we can concentrate and make it as a nanoparticle, and you can study the various properties like nature of the crystallinity, band gap energy, particle size, morphology, surface chemistry, surface area. So based on that, we can use this type of nanoparticle for the multiple application. That is the things is going on. So even from the energy and the environment and solar cell, based on the many medical applications, specifically the cancer studies and the antimicrobes and the composite material, we can use this type of green synthesis. These are all the common techniques which is used nowadays for the preparation of nanoparticle. So our work, so we concentrated, one of the important thing is that we can take the marine algal species. So it is the one of the sources we obtained from the Sargassum vigeti. So it contains the polysaccharide. Therefore, we use this type of material in the biological application. So addition to this nanoparticle, we can use the cellulose. So cellulose is one of the most abundant polysaccharide in nature. So it is recognized as a renewable, low-cost, non-toxic, and a renewable biopolymer. That's why we mix with this type of cellulose with the zirconium oxide nanoparticle, and we can use for this type of things for the study of the antibacterial and photocatalytic activity. There will be enhancing property we observe. So that's why I just want to give some brief introduction about how you make the nanoparticle and how you make the composite. Then after that, what are the antibacterial and photocatalytic efficiency we studied based on the various instrumentation, characterization techniques. We obtain the details. So one of the important thing in our work, we concentrated by using the very value-added cellulose in conjugation with the metal oxide nanoparticle. So here we mix with the zirconium oxide nanoparticle with the cellulose. That is a very interesting study. So highly stable cellulose zirconium nano composite, that is 1:1 ratio, synthesized from the Sargassum vigeti plant extract with the simple and cost-effective method. So that is the big advantage. This type of things. So preparation of nanoparticle and we make it the composite. That is very interesting one. So we extracted the material from the Sargassum vigeti plant extract. So it is by using this type of plant extract, the method is very simple and it is very cost effective. If you go in the bulk scale, so it will be very highly cost effective way we can do it. So whenever anything, the bulk, if you are going in the plant level, so I am the industrial scientist, whatever the things we can make it in the small R&D level, we make it as a production scale. So whenever there is some degradation efficiency or whatever the biomedical application, if you are seeing antibacterial activity followed by this type of photocatalytic efficiency will be enhancing, means it is very wonderful material for the future different application. The aim of the work I already mentioned. First, we synthesis of cellulose zirconium nano composite and evaluate its antibacterial activity against both gram-positive and gram-negative bacteria. That is our interesting core aim. So by using how to make the material, just to see, this is the preparation of Sargassum vigeti extract. So it looks like a edible brown seaweed was collected from Mandapam. In Tamil Nadu, there is the part of Gulf of Mannar region. So it is like the belt of Indian coast, Tamil Nadu. So this type of material we collected and dried for. So we make it the leaves, cut it into small pieces and powdered using electrical grinder. After you take it, the 10 gram of powder added with the distilled water, then normal procedure we adopted. Just you can heat the solution and you place the solution for 15 minutes. Then the extract was filtered and collected, were stored in the organ atmosphere for further use. This is the way in which any plant extract generally. So in our work also, we can take it like a wood extract from the various type of plants. So based on the solvent, we can use it. But here, with this very simple method, just to make that material powder and cut it and take it there, powder of material and we mix with the water and we did it there. Just eating and extracted whatever the content from the leaves we will extract. That is our intention. So we collect the extract and we use in our application. So I already mentioned there are two parts we concentrate, the synthesis of zirconium nanoparticle. So it is by using this type of zirconium nanoparticles were prepared by simple precipitation method using sargassum pigment plant extract. So here we already collected the leaf and we make it the extract. So from the experimental part, just to 25 ml of leaf extract was dropped slowly into the aqueous solution of zirconium oxynitrate under constant stirring at room temperature. So the whole thing is kept in Teflon linked autoclave at 150 degree for 12 hours. So we obtained the precipitate was washed several times and dried in oven 500 degree for 5 hours. So this is the way in which we produce the synthesis of zirconium nanoparticle. So how the process was conducted, just a pictorial representation, just we can see it. So from the zirconium oxynitrate, just to take it the material, and we added the leaf extract slowly and heated 150 degree, and again heated, we finally ended with the zirconium nanoparticle. So this is the pictorial representation. Whenever you are taking any plant extract, you mix with any oxynitrate material, we make it our needed the zirconium oxide nanoparticle. So the size of the particle is measured by using the various advanced characterization technique like SEM, scanning electron microscope. We can use it and find it out there. Make it the material in the nanoscale. That is our intention. So we did it for this type of things. So with this, so we prepared our zirconium oxide nanoparticle just to make it the composite purpose. So whenever any nano composite, it enhances the property. That is our purpose of taking this type of material. So here, very interesting, zirconium oxide nanoparticle embedded in the cellulose polymer. So that matrix were prepared by co-precipitation method. That is a very interesting one. So 2 gram of cellulose pulp, it is a commercially available cellulose pulp. Just you take it there, 98 weight percentage of cellulose was soaked with 100 ml of solution, mixed solution containing 80 ml of water, 10 ml of ammonium hydroxide, 6 ml of NN dimethyl acetamide, and 4 ml of urea, and stirred vigorously at 50 degree until to obtain the transparent cellulose solution. So this is the preparation method. So just we are taking the cellulose bulb. So we mix with the different type of solution based on the literature collection. Just we get the information. So we mix with the solution with water and ammonium hydroxide, NN dimethyl acetamide, and urea. So stir this vigorously at 50 degree until to obtain a very transparent cellulose solution. So that is very during the laboratory work we observed. So that type of material just washed with the water and centrifuge and cooled to 0 degree. 5 gram of zirconium nanoparticle was added to the cellulose. So we make it the cellulose solution, just to add it the zirconium oxide nanoparticle, stirred for 1 hour to obtain the homogeneous solution. So that is the composite, making the composite. So after that, the resultant nanocomposite solution were washed with deionized water. So we heated 100 degree for 1 hour. Then this is a common procedure for the making the composite. So now we prepared the zirconium oxide nanoparticle and we mix it to make it with the solution of cellulose. So we obtain finally cellulose zirconium nanocomposite. So now we prepared the material, then application wise, after that we characterize by using the different type of characterization technique. So still there is a work is going on. Some more, there is a big improvement we observed. That is our finding. So this is the way in which you make it this type of zirconium oxide nano composite. So initially I already mentioned, initially we prepared the zirconium nanoparticle. So you make it with the soaking with the cellulose. So finally the cellulose, it looks like a coagulating bath. You will see the formation of cellulose like a membrane. So that is the thing. This type of thing we use for the antibacterial activity studies, and also we studied for the main thing is the photocatalytic efficiency purpose. Some degradation, some dye we can take it. So we took like a methyl orange. So one of the dye. So how the degradation will be taking place by using the methyl orange. The first few studies we obtain up to 70%. There will be still enhancing property. Just I want to share some of the things alone. Some more very interesting things are going on. So based on that, I already mentioned, based on the various characterization, one of the important characterization techniques by X-ray diffraction technique we used for the. So we just compare the cellulose and the zirconium nanoparticle and cellulose zirconium nanocomposite. That is the three things. Based on the XRD pattern, we can see the result. So whatever the result we obtain, it clearly shows there is a different planes of cellulose crystalline form. Similarly, we observe the diffraction peaks observed at 2 theta value. Based on the 2 theta value, it is very corresponding to different plane 101, 102, or 211, 200, 102 plane respectively. So this type of data very clearly indicated that zirconium oxide nanoparticle are indexed tetragonal structure, that is confirmed by JCPDS card number 791769. So the sharp and high intense peak of cellulose zirconium nanocomposite obtained at 31.1 degree, at 52.3, 57.4, 62.3 and 75.5. It has the cubic structure of zirconium nanoparticle and other peaks corresponding to the cellular to polymer matrix. So this type of things very clearly observed that there is a differences between the both cellulose and a cellulose zirconium composite. So based on the infrared spectra, FTIR, Fourier transform IR studies, you observe the peaks. So there are different peaks we can observe just to index the peak like 3342. So it is generally everyone knows the OHP comes in the functional group, it almost 334. The other peak obtained around 1428. It shows the C double bond stretching, and 1049 shows the corresponding to CO stretching vibration. So the absorption peak at the 580 could be assigned intrinsic stretching vibration of zirconium oxide tetrahedral sites. So this type of the characteristic peaks of cellulose appear 3350 on the 2900, 1430, 1021 attributed to the OH stretching, CH stretching, CH bagging, and CO stretching respectively. So which are everything associated with the cellulose. So it is very clear information. We can get it from the IR study also. So the morphology, so by using the scanning electron microscope and a TEM analysis, we observed the cellulose, the number A, the picture shows that this is the morphology of cellulose A, B is the zirconium oxide nanoparticle, C is the cellulose zirconium oxide nanocomposite. So the final is the TEM image of cellulose zirconium oxide composite. So from the morphological studies, it is very clear that the zirconium oxide nanoparticle was spherical shape with a size range between 30 to 50 nanometer. So it is very clear indication that the cellulose zirconium nanocomp is the sample as the spherical in nature. So there is no agglomeration in the SEM analysis also. So the nano-sized spherical structure are beneficial for antibacterial activity and photo degradation. So since the voids between adjacent nanoparticles allow the efficient transport to reactant molecules. So whenever this type of nano-sized material which is used already, we did it for the many degradation process. We observe this type of things. No? So whenever it goes the nano size, we can get it the photo degradation application. So our interesting is one more thing is the antibacterial activity. So the UV visible spectra also very clearly indicate the spectra for the zirconium oxide nanoparticle and the cellulose zirconium oxide nanoparticle. The picture one, the top one, you can see the absorbance and the against the wavelength. It clearly indicates that the UV visible spectra for the zirconium oxide nanoparticle and the cellulose zirconium nanocomposite mostly exhibited the maximum range of 200 to 800 nanometer. So however, peaks of zirconium oxide nano absorption peak. So the picture we can see the 258 nanometer. So rod-like cellulose zirconium nanocomposite peak around 288 nanometer. So the band gap value also obtained for the zirconium oxide and a composite material. So it is almost, it comes under the 4.81 electron volt under the 4.31. So photocatalytic activity. So this is very interesting one. You obtain from the picture the degradation rate of methylene orange by green synthesized zirconium nanoparticle and cellulose nanocomposite. We observed that the value almost I already mentioned. This type of the degradation rate of methyl orange over cellulose zirconium nanocomposite and zirconium oxide nanoparticle reaches within the few studies. We obtained 76% and 66%. So within 15 minutes and 80 minutes illumination. So under the 50 minutes, it possesses the maximum saturation. So further studies are going. So we almost get it more than 90%. The work is going on. So just for introduction part of thing only, I just to take it as a methyl orange, one of the dye used for the degradation studies. So this type of degradation efficiency, zirconium nanoparticles are too. Okay. So I hope that this type of degradation study we observed. So antibacterial activity for cellulose zirconium nanoparticle, cellulose zirconium oxide nanocomposite against the Bacillus cereus and Salmonella typhimurium, the two bacterial study. The inhibition zone of zirconium oxide nanoparticle is very clearly mentioned. So cellulose zirconium composite 22 mm and 80 mm respectively. So this type of work very clearly indicates that the antibacterial result suggest the green synthesized nanocomposites are efficient antibacterial agent to treat the infectious diseases caused by Bacillus cereus and Salmonella typhimurium pathogens. That is our interesting work is going on. So finally, I want to conclude. So just to prepare the material by using the synthesis to take the leaf extract with mixed with the cellulose and you make it the cellulose zirconium nanocomposite by using the co-precipitation method without capping agent. So I already mentioned this type of work is very simple, eco-friendly, fast and efficient method. So this is the one of the important material nowadays. It is very interesting and it is very innovative. You can work for this type of material for antibacterial studies. So everyone zirconium oxide we can use for the multiple application in the most of the ceramic materials wherever there needs the high strength based on its melting point. No, it is more than 2,500. So that's why this type of thing is widely used. So, but we altered this type of material with mixed with the cellulose for the antibacterial activity. So this work was confirmed by using the various advanced characterization technique, and very clearly we obtained the size also. So we got in the material, the size of the particle is below 100 nanometer, most of the work. So due to the nanoparticle size, naturally there is based on the surface volume ratio, there is enhancing efficiency in all aspects. So our finding also from the plant mediated green synthesis of this type of cellulose zirconium nanocomposite, very strong antibacterial activity. Again, we concentrate only two different types of bacteria in this work. So what I am we insisting, this type of material we can use for the multiple antibacterial application purpose. Even we can use this type of things for degradation, means we can use for the dye degradation or the wastewater purification. Many biological application you can use this type of things. So that is the overall our work very due to the time factor, within the half an hour they want to finish up it. Just a few things alone we executed in the conference. I am really congratulate this type of program. So I am my sincere thanks to the organizer for wonderful opportunity given to the work. Thank you one and all. Thank you very much.
Hello, thank you, Mr. Sukumar. Is there any questions from audience? Please let us know. Okay.
I have a small question to Dr. Kamal, if it's possible, of course.
Yeah.
Dr. Kamal, thank you for this interesting presentation. I wonder I have just a question about the infrared spectrum of the synthesized nano composite between zirconium oxide and cellulose. There is no hydroxide group in this spectrum.
No, the cellulose, it contains more OH. When we are using this type of composite, no. So suppose I am using the water solution, means naturally it contains the OH group, it shows the ER. So the pH around more than 3,300, it shows the peak, no. So the composite side, we can see the hydroxy group also.
Thank you.
Once again, I thank you for the organizer. Thank you for the viewers. Thank you very much.
Thank you, Mr. Sukumar. Okay. Okay. Now I'm next participant is Anatoly Stotsov. I now take this immense pleasure of inviting Anatoly Stotsov. He's from GK Gorbachev Institute of Catalysis, Russia, to deliver her talk on H2S, a new insight into its role in human activity.
Они, по-моему, тебя просят уже. Next presentation is yours.
Окей, да, ты говори, да.
Давай, общайся.
Hello?
Yes, we are hearing your voice. You are audible. Your voice is audible. You can go ahead.
Один из этих вот скажите. Я же не сказал. Кажется, here. I can present my lecture. Is it possible or not? Just now. Hello, CATCHEM here. I'm ready to start with my presentation. Is it possible just now or no? Hello. Hello. CATCHEM
Yes, yes,
here.
yes, we are hearing your voice. Your voice is audible to us. Can you please continue with your presentation?
I can start with my presentation or not? Can I start with my presentation? Так, вы запустили. Пересмотрим, не зашел. Hello, dear colleagues. Is it I can start with my presentation. Is it possible or not? Shall I start? Shall I start?
Yes, yes.
At that time, H2S is one of the most toxic substances produced as byproduct in industry in large amounts. While its content in nature is estimated in tens of billions of tons. Unlike water, H2S is a useless substance that has not found practical application in life. Therefore, it must be removed from waste gases and water to the level of the sanitary standards. This process was found in the 19th century and still has been used all over the world, over 1,000 years. However, these levels hydrogen, the generally accepted energy carrier, and available can. Therefore, the great efforts of many generations of researchers have been directed to obtain the product in demand, hydrogen and sulfur. Some reviews of H2's processing are presented. To achieve this goal, various methods of initiation this reaction were used. However, none of these technologies has received commercial application. It is well known that any chemical reaction can occur if only the system receives energy from the outside in one form or another. In the final state, the system is characterized by a decrease in the Gibbs free energy. Higher process occurs spontaneously. In turn, all biological processes and the vast majority of industrial chemical processes are catalytic. According to the modern definition, catalysis is considered as a selective acceleration of one of the possible thermodynamically resolved directions of chemical reaction and the direction of the catalyst. It is important to emphasize that catalysts accelerate reversible reaction both in forward and reverse directions. Therefore, they do not shift the chemical equilibrium and do not change the thermodynamic parameters of the process. The logo of the Institute of Catalysis is shown on the bottom right, which is a paradigm of all researches carried out at the institute. However, The regularities of which the composition on the surface of solid galaxies found by us could not be explained. A typical example is the thermal decomposition approach to it. This equilibrium thermic process is characterized by a high positive value of the diffuse free energy and occurs only at high temperature. Divisibility means that the reaction proceeds in all directions, always near equilibrium. To shift equilibrium to the right in order to increase the yield of hydrogen, various methods of separation direction products are used.
Hello, Dr. Anatoly. Sorry for the interruption, doctor. So we are unable to hear your voice properly. Can you check your audio, please?
At the end of the 19th century, the Vinogradsky discovered a unique chemical process of chemosynthesis of organic matter from hydrogen sulfide and carbon dioxide, which, unlike photosynthesis known at the time, did not require the energy of sunlight. As believed, atrophic bacteria use the first organism producing large amounts of organic matter, and hence they provided the starting point for the evolution of higher life form. For the time being, there is a wide range of different types of cyanobacteria with very diverse properties and with equally diverse environmental habitats. The common cyanobacteria are found in marine and freshwater sediments, soils, and wastewater treatment systems. They are grown in aqueous media from acid to alkaline pH values at temperature ranges from +4 to +95 Celsius. Both are Therefore, we have every reason to believe that there should be catalytic systems capable of splitting H2S at room temperature. Let's consider these results. In contrast to the high temperature process, we obtained very unexpected results when passing H2S at room temperature through sulfur or metal catalyst. Along with hydrogen, the reaction products were either solid sulfur or diatomic sulfur in the ground treated state. In both cases, H2S conversion reached 100%. Since both reactions are carried out at low temperature without supply of thermal energy from the outside, a reasonable question arises. Where does the energy for this reaction come from? We could prove by special experiments that the reaction proceeds at the same efficiency in the dipole, which excludes the possibility of contradictions. This table summarizes theoretical calculations of thermodynamics of all elementary steps of H2S decomposition of sulfur catalyst. In contrast to the original work, this table contains an additional column that indicates the value of the bound energy, which is dissipated in environment at 300 Kelvin. I will not comment on this table as it will take too much time. The results are described in detail in my publication. Here, I will only note that the total exothermic reaction is characterized by a negative value of the Gibbs energy, which means the spontaneous nature of the process. The simple process is impossible in the gas phase. Thus, the energy profile of H2S decomposition on sulfur catalyst at room temperature is as follows. The energy reference point is the kinetic energy of H2S in the gas phase and its potential energy stored in the chemical pools of the molecule. We see the first three stages of H2S decomposition do not require external energy input and proceed spontaneously with a decrease in the Gibbs free energy. The only energy consuming stage is the decomposition of adsorbed disulfide as the K-surface intermediate. This step proceeds through a small energy barrier due to the free keep the energy accumulated in the previous exothermic stage of H2 dissociation. For comparison, the classical energy profile of hypothetical chemical reactions. In general, the catalytic reaction is an exothermic process that occurs spontaneously at room temperature despite a decrease in entropy that is dissipated from the system into a variable that abound waste energy. Even more amazing results we obtained using metal catalysts. As an example, here is the results of the decomposition of H2S at room temperature using stainless steel sheets as a catalyst. The reaction was carried out in a gas phase mode in the calculations unit. A gas mixture of argon and hydrogen sulfide continuously fed into the circulation lab. The reaction products are continuously removed from the circulation lab and analyzed chromatographically. In the lab, the gas which circulates at very high rate secretly through the catalyst and adsorbent of gaseous sulfur. The placement of an adsorbent in the circulation lab makes it possible to significantly shift the equilibrium of H2 decomposition reaction towards obtaining the target product, hydrogen. Decomposition of the gas phase at the outlet of the circulation lab. It's shown on the left. Sulfur adsorbed by aluminum in various experiments shown on the right. This experiment combined with infrared spectroscopy data definitely prove the existence of the atomic gaseous sulfur. One of the most outstanding articles on H2S decomposition was published in 1986. It examines the behavior of adsorbed H2S on the surface of arsenic crystal, platinum depending on temperature and surface coverage with H2S. At low coverage, H2S is completely decomposes on the surface of two molecular hydrogen, which is dissolved from the surface at 300 Kelvin. As the surface is covered with absorbed H2S, part of H2S is dissolved in the liquid mode in molecular form, but the main part of it manages to dissociate with the formation of hydrogen, which is dissolved from the surface at lower temperature. They clearly indicate that the formation of molecular hydrogen in the surface at very temperature even at 200 Kelvin. The chemical state of sulfur is not discussed in the paper, so shall we try to understand its nature and the basis of the chemical properties of H2S. The fact is that the appearance of molecular hydrogen in the gas phase can be caused from the H2S decomposition, yielding the formation of monatomic sulfur, which should be related in the formation of the surface platinum sulfide, as required by the stoichiometric chemical reaction of platinum oxidation with hydrogen sulfide. However, it is well known that hydrogen sulfide exhibit only reducing properties since sulfur is in the lowest oxidation state. Hence, the reaction above must be catalytic one with the formation of atomic zero valence sulfur as a product of H2 decomposition. This applies to all transition metals. It's very important. Water on metals doesn't dissociate to atoms. The last time, a lot of publication devoted to the study of the interaction of H2S molecules with the surface of sodium crystal, DNT-activists, had appeared in the literature. The characteristic feature of H2S adsorption on the surface of transition metals is that the consorption stage is accompanied by a further process of dissociation resulting in the formation of surface species. Dissociation occurs in two stages. Each of these determined stage occurs through a small energy barrier and results in the total energy decrease of the catalytic system causing in the accumulation of the energy of the metal surface. It's very important that dissociation of H2S into atoms has neither thermodynamic nor kinetic restrictions. The energy of H2 dissociation is given for platinum, since it was on platinum that we discovered the H2S decomposition. We see that a result of spontaneous endothermic states of absorption dissociation of H2S molecule about 60 kilocalorie per mole accumulates on the platinum surface. Similar DFT calculation of H2S interaction in the surface of various metals can be performed by many researchers. The result of some of them are summarized in the table. As we already noted, both metals and H2S are reducing agents. So the process of the absorption and dissociation of H2S on the surface of metals could be catalytic, provided that the energy stored in the process of absorption and dissociation of H2S will be sufficient for the absorption of reaction products into the gas phase. To answer this question, it would be necessary to calculate the entropy change at all stages of H2 decomposition and product absorption to determine the Q3 energy at each steps of the catalytic cycle, as we did earlier for sulfur catalysts. However, since this cannot be done in the near future due to the author's lack of such a capability, we will try to justify the implementation of the catalytic cycle from the point of view of thermal chemistry. As is well known, the energy of chemical bonds in the molecule is one of the ground molecular constants characterizing the structural features and the reactivity of chemical compounds. The dissociation energies of most molecules in their radicals are given in the reference tables. In the reaction considered of two H2S molecules, four less H bonds must be broken, which results in the total dissociation energy of two molecules roughly 350 kilocalories per mole. At the same time, two bonds HH and one bond sulfur-sulfur are formed. From its following, that the total energy of the bond dissociation of the initial H2S molecules exceeds this value of the reaction products at 40 kilocalories per mole. In other words, this means that the initial gaseous H2S molecule is stable. It does not convert into the reaction product H2 and S2 at room temperature. Therefore, the thermal energy is required to initiate the reaction we consider. However, in the absorbent state of the catalyst, the required energy for breaking bonds in H2S molecule can be obtained from the energy of absorption and dissociation of H2S molecule to the atomic state. Indeed, after dissociation of two H2S molecules into atoms on the platinum surface reaction, the resulting process gives rise in the energy surplus minus 77 kilocalories per mole, which can be spent for absorption of the reaction products into the gas phase. Actually, the energy of S2 molecule absorption in platinum is minus 45 kilocalories per mole. The head of dissociation absorption of H2 on platinum varies within minus 9 to 12 kilocalories per mole, while molecular value the solid surface even at 200 Kelvin. Therefore, after removal of nitrogen, sulfur, and two hydrogen molecules from the platinum surface, we obtain a minimum excess energy minus 8 to 13 kilocalories per mole, which means that the thermic process as a whole. Moreover, an additional gain of energy 12.6 kilocalories per mole should appear as a result of transition of diatomic sulfur from the excited semi state to its ground triple state in the reaction. Therefore, the resultant gain in energy can be estimated as minus 20 to 26 kilocalories per mole. this, the first law of thermodynamics for the open systems realized energy can be transformed from one mode to another, but can be neither energy nor wage. The simplest consideration of energy capture transformation in a surface chemical reaction gives a positive response to the thermodynamic possibility of these catalytic reactions at room temperature. Energy from the exothermic processes of absorption and dissociation of initial molecules is captured by the surface of metal catalyst and converted to provide the chemical transformation to the final reaction product formed by the resorption to the gas phase. Taking into account both the increase enthalpy of the reaction, the number of gaseous molecules increases, and the exothermic effect of the reaction, we conclude that the change in the heat free energy is always negative, which means that the catalytic reaction occurs spontaneously. That is what I need to prove. Undoubtedly, this conclusion was a comprehensive study by the theoretical and experimental methods taking into account the entropy factor and determining change in the initial energy at all stages of the reaction. This process is not possible in the gas phase. So, since these processes are impossible in the gas phase without possible dissipation of solid matter, therefore there cannot be substantiation by the equilibrium thermodynamics. Basically, equilibrium thermodynamics considers only isolated systems that exchange the material energy in the environment. These systems, chemical processes are carried out by supplying energy from the outside, so the rate and direction of the process depends only on external conditions in the catalyst that change the thermodynamics of these processes. At the same time, most of the processing occurring in nature are carried out at ambient temperature and pressure without the supply of thermal energy from the outside. All biological processes are far from equilibrium if have an irreversible character. Therefore, non-equilibrium thermodynamics of irreversible process was created in the middle of the last century. One of its creators is Prigozhin. The distinctive feature of non-equilibrium thermodynamics are that the system considered by it are open to the flow of matter and energy, and the processes are irreversible and far from equilibrium. The delay of the emergence of physical science was due to the understanding that the vast majority of processes occurring in nature and with human participation are irreversible and cannot be described within the existing classical equilibrium thermodynamic method. Within the framework of non-equilibrium thermodynamics, we have developed the concept of the clashing role of catalysts in the process of temperature composition of fluids. So the role of catalyst becomes clear on the surface of which chemical reactions are carried out, which are impossible in the gas phase in the absence of catalysts. The main features of the concept. H2S conversion can be realized only on the surface of solid catalyst. This process is possible in the gas phase. H2S conversion is materialized due to the free and internal energy of this molecule without consuming energy from the outside. Since the reaction is bimolecular at one of the key stages of H2S conversion, the efficiency of catalyst depends on the coverage of surface with absorbed H2S, which is provided by the temperature. The lower the temperature, the higher the efficiency of the catalytic system. Important. The H2S conversion is determined by the concentration of active center on the surface of the catalyst. So 100% conversion of H2S is achieved by loading the required amount of catalyst. The ground force of the process is the formation of reaction products in the ground electronic state, having minimal energy. synthetic hydrogen, solid sulfur, and diatomic gaseous sulfur in the ground liquid state. Concentration gradient at the input and output of the system are a necessary condition for the reaction. In the absence of free energy supply, the process is stopped. The active role of the catalyst in the orbital system provides capture and kinetic energy of the substrate molecules, spontaneous and determined absorption. Ensures the spontaneous course of endothermic process of dissociation of molecules to the atomic state, solid state. Ensures the accumulation of free energy due to the continuous discharge of entropy, the dissipation of bound energy into the environment. Provides redistribution of internal energy for the formation of new compounds in reaction with products. The free energy stored during dissociation of substrate molecules is used for the desorption of reaction products into the gas phase. The efficiency of this system against external forces is ensured by the continuous supply of free energy in the form of the internal energy of the substrate molecules. The logical results of our scientific researches is a patent describing examples of catalytic system capable of decomposing hydrogen at low temperature to produce hydrogen and elemental sulfur. This patent contains references to our previous patents on this problem, which indicates a large variety of catalytic systems that can be used to implement the process in various ways. Let's now return to the process of chemosynthesis. The sulfobacteria consume HTS as a source of energy and hydrogen, and then produce elemental sulfur as an intermediate product. Sulfur is deposited as whites of globules located either inside or outside the bacterium cells. Similar globules of white sulfur will obtained by decomposing H2S at room temperature on metal catalysts placed under a layer of water. The size of spherical globules of white sulfur, almost regular shape, reaches 10 microns, while the smallest particles are transparent and alkalis. Electron diffraction on a separate globule of white sulfur indicates no hexagonal structure. This electropic modification of white sulfur is not described in the literature. Further hypotheses about the mechanism of chemosynthesis are discussed in the literature. We will not dwell on them. We will offer our own version of the implementation of this process in the future. We found fundamentally new catalysts that turned out to be insensitive to the atmosphere of carbon dioxide while maintaining their efficiency in the H2 decomposition with 100% conversion. This gives some optimism in the creation of low-temperature catalytic system for processing acidic H2S containing gases to produce hydrogen, which can be used in situ for the assimilation of carbon dioxide and the synthesis of organic molecules. However, these exploratory studies will possibly stop influence of external forces hostile to the science. These studies were blocked by the Russian Academy of Sciences, which is a strange position of its leadership, which is reflected on the available slides. The primary task of our project is to replace the long, outdated, expensive, overrated, metal and energy-intensive house image with an innovative temperature technology for processing toxic H2S to obtain the charged hydrogen. This will make it possible to obtain at least 5% of hydrogen in addition to existing needs without involving new hydrogen processing. The application of these methods has no climatic, geographical, or other material limitations. The technology is applicable anywhere in the world where there is an industrial processing of raw material with the extraction of H2S. There are no analogies of this technology in the world. Legal protection. The objects of patenting are both the chemical composition and technology of preparation of catalyst, as well as methods of technology for the implementation of the process itself. To date, there is no foreign protection of intellectual property rights. After the implementation of the project, the main market for sulfur continue to be its catalytic processing into sulfuric acid. In addition, gaseous sulfur can be used for the synthesis of new chemical compounds of sulfur, analogous of biological objects, medicine, composite materials for various functional purposes, including lithium sulfur batteries, in agriculture, in the rubber chemistry, for the production of dyes, in industrial and road construction, etc. The market opportunities for the use of gaseous sulfur are far from its costing. It was due to the lack of scientific research. Additional activation of gaseous sulfur is not required. When H2S dissociates, atomic hydrogen is formed on the surface of solid catalyst, which has unique properties of interaction with very inert molecules at room temperature pressure. Nitrogen fixation is produced of ammonia and other nitrogen-containing molecules. These chemical compounds can solve the problem of storing and transportation of hydrogen superpolymers low pressure. Activation argon to produce hardened agonite, a molecule stable under normal conditions, which can be used for the accumulation, storage, and transportation of hydrogen. Moreover, when hydrogen agonite is burnt in the fuel cells or in the presence of oxygen, water and argon are released, which returns to the atmosphere without damaging the environment. There is reason to assume that chemical analysis neon hydrogen and heliohydrogen can be obtained in a similar way. Without a doubt, if these compounds really exist under normal conditions, this scientific discovery will give a huge impetus to the development of novel gas chemistry. The generally accepted paradigm of H2 decomposition to its constituent elements using ester energy sources has not allowed until now to create an acceptable technology for production of hydrogen and sulfur from H2S. The proposed paradigm of the low temperature catalytic H2S conversion is apparently the very tool to solving the extended argon problem is of not only the disposal of toxic H2S with production of demanded product, but also opens up a wide prospect of using atomic hydrogen and sulfur to realize unexpected chemical reactions in production of new, previously unknown chemicals. The development potential of the advanced paradigm is limited by the volume of H2S processed, which in turn is constrained by the volume of sulfur consumed. The situation may change if new unexpected solution will be found to use the triplet sulfur as a reagent for synthesis of new substances and materials in the industry, engineering, medicine, pharmacology, etc. On my website, information about the chronology of the development of works on temperature H2S decomposition, as well as some ideas and hypotheses that require close attention, as they can open new pages in the chemistry of H2S, hydrogen and sulfur, as well as in some related fields of chemistry, medicine, etc. Thank you for your attention.
Thank you very much for your attention. I'm close my presentation.
Yeah, thank you, Mr. Anatoly. Is there any questions from participants? Okay, if not there, we will continue with our next speaker. I call upon Rehan Asgar from Mirpur University of Science and Technology, Pakistan, to deliver on enhanced thermostability and enzymatic activity of C16A variant from Thermobulia Casca by empirical domain engineering. Short title: Domain Engineering of CE16A. Can you please click on your mic, ma'am?
Mute. Is that okay?
Yes, it's now visible. It's now audible. Thank you.
Okay. As you know, the topic of my presentation is enhanced thermostability and enzymatic activity of Sal6A variants from Thermobifida Casca by empirical domain engineering. I'm a professor emeritus here in the Faculty of Natural and Applied Sciences. I have done my master's from University of California and PhD also from University of California. I have already done postdocs from the US, two postdocs. Okay, this is just a brief introduction of my topic and myself. Let's move on to the next slide. It's not moving. Okay, global warming is a big concern nowadays, since we know that the global warming is ruining our environment and the friendly environment for the living organisms. Since we are using the fossil fuels, which ends up in releasing carbon dioxide, which covers about 65% of the contribution in the global warming. And nitrous oxide contributes 6%, methane 16%, while carbon dioxide 11%. And the other, whatever the pollutants are 11%, and carbon dioxide is 65%. So major pollutants comes from the carbon dioxide, which is produced as a result of the fossil fuels and industrial processes. The other thing is, which is also very alarming, is the methane. Methane is also contributing a lot in the global warming, although it is only 16%, but it is very harmful for our environment. And you know that the cattle and some of the crops which we grow also generate the methane in the environment, which is very dangerous for our environment. So this is a big issue right now. And, you know, this global warming has really affected the environments in throughout the world. Specifically, last year's rainfalls in Pakistan and India are also as a result of the global warming. As a result of these rains, we got floods. This has been already acknowledged by the United Nations that these unusual rains were because of the global warming. So it is a very alarming issue, and people are trying to tackle this in a different ways. So 98% of the carbon emission results from the fossil fuels. Carbon dioxide is the main cause of the human-induced climate changes. If we reduce the fossil fuel use, then that will reduce the carbon dioxide emission, and that will eventually reduce the global warming. This is one approach. Now, since we use the fossil fuels for the energy production, what is the alternative of the energy production? That is the question. Of course, solar and wind energies are the other options, which are the safe energies, which are not causing pollutants. But these two energies are not enough. We need more in order to produce, in order to run our industry, run our lives and our vehicles and all those things. The other option is to go for the bioethanol and biodiesel, which are the biomass-based liquid transportation fuels. These fuels are cost effective because their synthesis, their formation needs some input of the amounts, and however they are renewable. And this is the good thing about it, because renewable energies are very safe to use, and they are cost effective, and they are secure also. They have lower carbon emissions, and also they have wide range of source material which can be used to synthesize or to produce the bioethanol and biodiesel. What is biodiesel? Biodiesel is a fuel made from the vegetable oils, fats, or greases, which can be recycled in the restaurants, which can be get from the restaurants by the recycled grease. Pure biodiesel is not toxic, biodegradable, and produces lower levels of most air pollutants than the petroleum byproducts or the diesel fuels. Bioethanol is an alcohol fuel made from the sugars found in the grains, corn, sugarcane, sorghum, and barley. So we can use the plants, or we can use some crops also for the production of the bioethanol. This is a big question also, because people are concerned about it, because we don't want to use the edible crop for the bioethanol production, because if the farmer gets more benefit, more revenue to generate from bioethanol, instead of growing the crops for the food purposes, then that is not good for the life forms. So we need to use the part of the plant which is not used for food or which is not edible. Here is the part of the plant which is most promising for the production of the bioethanol, that is the plant cell wall, which consists of cellulose, hemicelluloses, and the lignin. Cellulose contains about 33%, hemicellulose is 28%, and lignin 24%, and some other components are there also. Now, cellulose is one of the major raw material for the production of bioethanol, because these are made up of the glucose subunits. Hemicelluloses are either the pentoses or hexoses. And lignin is a hard material which is present in the cell wall and can be used for the ethanol production. So what is the process of the biofuel production is you develop the crop, take the part of the crop which is not edible, and then deconstruct it by using the microbes into smaller particles, and then by using the enzymes you can deconstruct it into simple sugars. These simple sugars are further fermented by the use of the microbes to optimize their fermented byproduct, which can be used for as a biofuel. So this is the normal process of biofuel production. This is just an illustration of the cell wall showing you the celluloses and hemicelluloses and long chain hexoses, pentoses, within the hemicelluloses, crystalline cellulose. This crystalline cellulose is very, very important, which is 40 to 50%, and that is the one which is most promising for the production of the ethanol. If we go towards the lignin, lignin is about 15 to 25%, but lignin is a very hard material, and we do not have very good enzymatic reduction of the lignin, but we do have for the crystalline cellulose and hemicelluloses. Now, cellulose is the most abundant plant biomass found on the earth and is an extremely important for mankind due to its diverse applications. The non-food cellulosic plant biomass is a very attractive option for the production of biofuel. Biological depolymerization of the cellulose biomass is accomplished by various types of cellulases such as endoglucanases, exoglucanases, and beta-glucosidases. Now, among these, the endoglucanases is very important for us for the production of the bioethanol. I will talk about it in future slides. Endoglucanase cleaves cellulose polymer into oligopolymer, which is about 2 or 3 sugar in length, while exoglucanases attack the reducing and non-reducing cellulose yielding glucose or cellobioses. Finally, beta-glucosidase cellobioses into fermentable sugar monomers, and that is shown here with the illustration. Here you can see in the figure A, the cellobiohydrolases, exoglucanases, which are attacking at the non-reducing and the reducing ends of the crystalline cellulose, while the endoglucanases are converting the cellulose in the amorphous region into smaller subunits containing 2 glucose units or 3 glucose units. And further, the beta-glucosidases converts them into the simple sugars, which you can see here with the pink module. So what happens? There are some microbes, bacterium, which have these enzymatic modules attached with them. And these are the soil bacterium, which are very effectively involved in the fermentation of these cellulose. And here you can see in the figure B that with the wall of the bacterium, a long core protein is attached by a surface layer homology domain, and this one has modules for the various enzyme for the enzyme endoglucanase, and you can see there is the cellobiohydrolases, endoglucanases, and glucosidases. All 3 are attached here with this, and they attach with the cell wall and then perform their functions. But for the attachment, there should be a carbohydrate bonding module with this enzyme, because this is the structure which takes the core protein to the cellulose and binds it there, so the enzyme modules can work on these. Despite the tremendous potential of the celluloses in the conversion of plant biomass into usable bioethanol, their widespread application is restricted by their high cost and low of efficacy, especially under harsh industrial conditions. Enzymes with high thermostability are advantageous, and scarification processes owing to their better penetration ability into the lignocellulosic biomass for disorganization. Furthermore, plant biomass degradation at elevated temperatures reduce the risk of microbial contamination and cooling costs after biomass pre-treatment. So that is also important, that these enzymes should be active at the high temperature. And therefore, tailor-made cellulases by the molecular engineering will improve the catalytic activity, and thermostability is a prerequisite in order to be used in industrial applications. Here is the bioethanol production process. What you do is you take the plant biomass, pre-treat it with alkali and acids in order to remove the lignin, and separates the celluloses, hemicelluloses, and amorphous cellulose and crystalline cellulose. All these are the 3 components which these 4 components are formed by the pre-treatment. And then cellulose hydrolysis by the enzyme production and hemicellulose hydrolysis will produce the glucose fermentation and pentose fermentation. And after that, with the purification processes, we get the ethanol and the co-products which comes out from this. So in this case, amorphous cellulose is easily to break up, while the crystalline celluloses are difficult to be break by the enzymes. So that's why we need to use some microorganisms in order to enhance this breakdown of the cellulose. Thermobifida fusca is moderately thermophilic major lignocellulitic soil bacterium. It has been well known for its potential to produce various types of cellulases that can penetrate the cellulose and lignocellulose residues to yield simple scarification units. Among various glycosyl hydrolase families, endoglucanases, endoglucanase cell 6A of Thermobifida fusca is considered to be the most efficient reducing sugar producer, hence has the potential to be used in the biofuel industry. Structurally, cell 6A is a modular enzyme with a non-catalytic family 2 carbohydrate binding module, which is CBM2 at C-terminal. CBMs facilitate the adsorption of the catalytic domain with the substrate, help in the alignment of the enzyme substrate, colonize proximity, and carry out hydrolysis by modification of the substrate surfaces. There are very few reports on the enzyme engineering for industrial applicability, particularly to improve the thermostability of cellulases. Thermostable multi-modular cellulases provides an excellent template for the modification to enhance the suitability for industrial applications. Now, the scheme of study which we followed in our work was this non-catalytic family 2 carbohydrate bonding modules, CBM2, catalytic domain glycosyl hydrolase 6 of endoglucanase cell 6A, either deleted, inserted, or rearranged to engineer a suitable cell 6A that can withstand harsh conditions of pH and temperature for industrial application. So we have two units here, non-catalytic family 2 carbohydrate bonding module, and second, the catalytic domain. So these are the two with which we are going to play with and see which can give us the better efficient variant. Then engineered cell 6A variants were expressed and assessed their enzymatic activity. The cell 6A construct with higher thermostability was in structurally through long-run molecular dynamics simulations and insights of the thermostable behavior of the enzymes at comparable temperatures. Now, this is how the gram-positive thermophilic bacteria are constructed. There are many classes, major plant biomass degraders in the soil, which are shown here in the photograph also. Cell 6B, which is also called E3, it has carbohydrate binding module 2, and that is the GH6 is the glycosidic hydrolase or the catalytic domain. Cell 9A has the catalytic domain, carbohydrate binding domain, FN3 domain, and CBM2 domain. Cell 9B E1 has CBM4, IG, GH9, FN3, CBM2, and cell 5A has CBM2 and catalytic domain GH5. Cell 6A, which is the enzyme which we have used, has two domains. It has a catalytic domain, GH6, and carbohydrate binding module 2. There is cell 48A E6, which has the CBM domain, XX, and the catalytic domain. Like this, there is Zin10A, catalytic domain, and CBM2. Zin11A has the catalytic domain GH11 and CBM2. So these are the various enzymes which are which have multi-domain structures, and this gives an advantage for the production of the biofuel also because of the domain structures. So we picked the cell 6A for our studies, and here is the structure of it. Catalytic domain, which is shown here in the green, has a basically it links with the peptide. It gives a spring action to the enzyme and provide flexibility. It interacts with the substrate and the water. So it is the main catalytic domain which performs the function. Then the binding domain. Binding domain is basically involved in the adsorption of the enzyme, mobility on the cellulose surface, and facilitates the catalytic domain in that. However, there is so what we did was we designed the primers with specific restriction sites in order to make various constructs of the enzyme. By using these primers, we were able to do these constructions in domain editing scheme, which we followed here, in which we have done 5 processes. First is the truncation, then transposition, then addition, and other addition, duplication. What we did in the truncation, as you can see, the blue bar is basically the catalytic domain, and the green portion is the CBM domain, and black line here is the linker. So in the first case, by using the primers, we have truncated and removed the linker and the CBM domain, and only the catalytic domain was there, which we have used for further processes. In the second case, we have did the transposition. In the transposition way, what we did was we have moved the linker and the CBM domain from the C terminal to the N terminal of the catalytic domain. And this is how we did it. We cut the linkers and linker, and we cut the catalytic domain and then rejoined it by using the various enzymes on the nitrogen side, from the C side to the N side of the catalytic domain. So that is the transposition. We have just moved the position of the CBM and the linker from the C position to the N position of the proteins. Then CBM addition. 3 is this process in which what we did was we have added the CBM2 on the both sides of the catalytic domain. As you can see, the green and the linker has been added on both sides. So this is the cell 6A-BCB construct, while this one, the transposition one, was the cell 6ABC construct, and our truncation was cell 6AC. Then again, we have done another addition. And in that, what we did was we used the catalytic domains on both sides with the CBM domain and the linkers in the middle. As you can see here, the construct cell 6A CBC was made by the 2 catalytic domains, which were placed the CBM domain in the middle. Then duplication. In duplication, simply we have added an other catalytic domain and the CBM domain side by side and made their duplex. That is the cell 6A CBCB. So these were the 5 constructs we made, and then we injected these, we inserted these in the plasmid, and the plasmid was the vector IPTG plasmid, and that plasmid was inserted in E. coli and let the E. coli to multiply them and amplify them. We have obtained the confirmation of the expressions of these domains, these additions and deletions, which we have done by this agarose gel, showing the restriction map generated by the digestion of the plasmid cell 6A by using the P cell 6ABC, P cell 6BCB, and P cell 6CBC, and P cell 6CBCB with NAD and HinD3 restriction endonucleases. And you can see in the first construct where we have only the catalytic domain, the product was about 0.86 kb. And this is the, it means that the value of the CBM binding domain was deleted from it, and we have only the catalytic domain. Our vector size was 6.5, and cell 6A native is about 1.3 kb. So we have reduced here the size of the construct. Then we have done the sequencing of the construct. The next is the cell 6ABC, in which we have added the catalytic domain, and also we have just transformed the CBM2 domain from the C terminal to the N terminal, and the size was 1.3 kb. In the third case, where we have used the catalytic domain in the center and the two CBM domains on the sides, the value was 1.7, while where the catalytic domain was on the sides and the CBM domain was in the middle, the size was 2.2 kb. Here the size has been increased because we have two catalytic domains in the third and the fourth column. In the fifth column, we have just duplicated it, and there is a very small increase, 2.6 kb in the construct which we made. So this is showing that the size has been increased in the product which we made as the cell 6A CBC, which has two catalytic domains. And then we looked at the expression of it by adding them, by inserting them in the plasmids, and plasmid was multiplied in the bacterium, and we took the whole proteins of the bacteria, and it was found that our construct, our product was in the soluble fraction of the bacteria. It was not in the particles. And you can see untreated bacterium. First is M is the molecular weights, U is the untreated, and C is the construct which we made. And you see at about 30 kilodalton, there is a big increase in the protein. So it means here the bacteria was synthesizing the construct which we made, because we have added the promoter here, which is enhancing the replication of the same product. And that was our first construct. The second, where we have transposition the CBM domain, we can see the size has been increased about, product size has been increased about 50 kilodalton. And then where we have two CBM domains, the size has been increased, and it is about 60 kilodalton. And the fourth construct, where we have two catalytic domains, there is a tremendous increase in the expression of our construct, because the two catalytic domains were there in between, having the CBM2 domain. And the last one is not increased so much because we are not having any changes in it, only this main domain of the main two domains of the cell 6A with the one catalytic and the other is the CBM2 were there in that. Okay, we have tested it on the substrates also, the activity of the enzymes. And here in the cell soluble proteins, we can see the activity is quite high. In the AC construct has 170, cell 6ABC has 168, and cell ABCB has 190, and cell 6A-CBC has 185 and CBCB has 180. So the highest activity was in the BCB, and expression level of the variant in soluble protein is also shown here very well. So that was the confirmation that our protein was in the soluble fraction, it was not in the particles. Then we looked at the this was the liquid substrate, and then we used the solid substrates, which is endoglucanase activity was tested on solid substrates with carboxymethyl cellulase is one of them, and you can see the highest activity was in the cell 6A-CBC construct, which is 600, almost double that of the cell 6AC, and the activity was not increased much in the cell 6A-CBC because there was nothing increased in the catalytic domain here. So where there are two catalytic domains, the activity was almost doubled, increased. Specific activity of the enzyme was also high at this stage. Filter paper results and the bagasse and the bacterial micrae has given us the same, almost same results as we get it from the carboxymethyl cellulases, where the highest activity was in the construct containing CBC. Then we checked the effect of temperature on the activity of the enzyme endoglucanase activity, and as you can see by this presentation graph, you can see the activity was higher from 55 degrees centigrade to about 70 degrees centigrade. The activity of the enzyme was above 80%. So that is a very long range for the enzyme, for its activity. It is a long range of temperature, which is good for any enzyme which can be used in the industry for the production of the biofuels. Then we have looked at the residual activities of the enzyme. We let them, the constructs were placed in the solutions at various temperature. Depending upon the durations, we have increased the time period from 20 minutes to 40, 60, 80, 120. And then we looked at the residual activities. And as you can see in the first one on the left side, the top one, cell 6A-CB, there was a sudden drop in the activity at 50 and 50 and 70 degrees centigrade, 70 degree and 75 degree. There is a sudden drop. At 65 degree, there was less drop, but the activity was quite straight in the beginning, and then very less drop at 60, 55 and 50 degrees centigrade. And if we compare all these for our constructs, we can see we can have a better results in this one, where the drop in the activity was gradual. The third graph on the left side, you can see that is the cell 6A-CBC. There was a very gradual drop in the activity, while the others have sudden drop in the activity with the increase in the temperature. So this is also a good sign for this construct can be used for the bioethanol production because it has a residual activity for high temperatures. Then we looked at the physical characteristics like the effect of pH on the hydrolytic enzyme activity against the CMS. And here you can see the pH range is above 80 from pH 5. Enzyme activity was above 80% from pH 5 to almost pH 8. So this is a long range of the pH in which the enzyme was quite active and it has a higher activity. That is also a very good sign. Then we did some molecular dynamic simulations which were performed at 4 different temperatures, 26.85, 60.85, 74.85, and 126.85 degrees to develop the most effective rationale for the assumption of the impact of factors governing the enzyme thermostability. The dynamic consequences of the enzyme construction were explored by calculating the root mean square deviation and root mean square fluctuations, values for all carbon backbone atoms to identify the thermal sensitive regions as performed in some earlier studies also. We did that. MD simulations have been used in several studies, evaluate the factors regulating the thermostability of the enzyme and to investigate the stability of the biomolecular complex and interaction attributes. This is the bioinformatic parts which we have done using various softwares. These include the thermal stable mechanisms, and there are some examples are given here like rubridoxin, nuclease, Barnase. These are various enzymes which are already being studied by using these molecular dynamic simulations. And this is the time-dependent all backbone atom root mean square deviations of cell 6A CBC. So we are dealing with the CBC. You can see the fluctuations in the root mean square deviations and root mean square fluctuations as the function of residue number of cell 6A CBC at different temperatures. Each trajectory is colored as followed by different temperatures. 4 temperatures I have told you earlier: 26.85, 60.85, 70.85, which is the blue, which is the green, and 126.85 is the red. Red, green, blue, and the root mean square fluctuations are less at a temperature which is low, and it is higher at a temperature which is at a higher temperature. Fluctuations are also high. The result obtained showed that the cell 6A is the most active on soluble and insoluble cellulosic substrates. Cell 6A CBC exhibited highest catalysis of carboxymethyl cellulose. CMC at a pH 6 and 60 degrees centigrade was the best. Furthermore, cell 6A CBC showed good thermostability at 26.8, 60.85, 74.85, as well as structurally flexibility at 126.85 degrees centigrade by molecular modeling assay. Therefore, thermostable derivatives of cell 6A engineered in the present work showed the better performance and can be used variant for the production of bioethanol from cellulose. Here are some structural illustrations, molecular surface representation of cell 6A CBC construct with catalytic domain are colored as the orange, and which is the N terminal of the protein, and the cauliflower blue color is the C terminal, while the green portion is the domain which is CBM2. The carbohydrate binding module 2. The initial conformation before molecular dynamics simulation was this. The original construction was shown in the figure A. As you can see, all the three structures very well. The conformation cell 6 CBC at an optimum temperature 60.85 degrees centigrade. B is the construction, what happened in the structure. As you can see, at the 60.85, you can see a very little amount of CBM2 portion. Then at 60.85 in the figure C, you can see the CBM2 on the top and the C terminal and N terminal sites, catalytic domain, and the green portion and the blue portion, which is the N terminal site, is shown here. At 126, you can see again the change in the conformation of the molecule. Docking conformation of the CMC substrate is the red sticks, which are shown here as CMC1 and CMC2 with N and C terminal catalytic domains of cell 6A, CBC respectively. The zoomed in on left and right displaying the binding site residues in respective catalytic domains. So with that, we can conclude that all cell 6A variants showed a broad range of pH optima with a pH range of 5 and 8, retaining more than cell 6A CBC, which retained more than 90% endogluconase activity in these ranges. The optimum pH for all of the cell 6A variants was 6.5. All the cell 6A variants showed more than 80% activity at a temperature range of 55 and 70 degree with optimum CMKs activity at 65 degrees centigrade. Cell 6AC with CBC, a new catalytic domain, showed slightly higher thermostability with more than 80% CMK study and incubation and more than 60% activity after 30-minute incubation. These results suggested that inclusion of an extra catalytic domain plays an important role in the thermostability, while additional CBM reduces its thermostability. So moreover, the MD simulation study showed an excellent rationale with the experimental results and endogluconase thermostable region at higher temperatures. The present study focused on thermostable cell 6A construct potentiate the mass production of bioethanol from plant biomass. On the other side, this study also identify the portion responsible for thermostability of the endogluconase variants from Thermophyta bifusca that may be the enzyme with enhanced thermosis. So it is basically the catalytic domain which increases the activity of the enzyme. And that's all. Thank you.
Yeah, thank you, Dr. Rehana Asgar. Is there any questions from audience? Okay, if there are no questions, we will proceed with the next speaker. I call upon Xiang Wu from Ethiopian Technical University, Ethiopia, to deliver a talk on improving the reliability design of mechanical systems. Yeah, hello, Xiang Wu. Are you ready?
Can I start?
Yes, yes, you can proceed.
Yes, yeah. Thank you to listen to my presentation. My name is Atu. Today, I briefly introduce of the U-derived methodology. This methodology improved the mechanical system. I will present the entitled of the improved reliable design of the mechanical system, such as a refrigerator. This is automobile. Automobile consists of the engine and transmission and driving and electrics, etc. Total component 20,000 pieces. Life target is between 10 years. To improve the performance, reduce cost, product will be designed yearly. By live testing and the engineer should find the design flow of the product module. This is the airplane. Airplane consists of the machine and door, aviation control, and the hydro control, etc. Total components of 200,000 pieces. Life target is between 10 years. This is a refrigerator. Refrigerator is consists of the cabinet, and door, internal fixed, and the general part, etc. Total component 2,000 pieces. Life target is between 10 years. This is definition of the reliability. Reliability can be defined as ability item to perform the required function under the state, environment, and operation condition for the specific period of the period of time. Product reliability can be described as a best of. It's by far of the best ofs, and the product will be rejected from the marketplace because of the initial failure rate, higher failure rate, and the short lifetime. Because of that, the company set up the cost plan, and as the design improved, the best of is changed to the straight line. Product reliability can be achieved without design failure. This is a sinking picture of the RS Titanic in the 1912. It came from the cold sea water, brittle steel for the temperature. Stop the side of the Titanic struck in the iceberg. And as a result, and the RS Titanic and 2,000 people on board, it takes 2 hours, 40 minutes, and sinking to drown to death, and more than 1,500 people. This is just of the challenge. It came from the lucky boost sealed with two lava, brittle o-ring, and under the winter weather. As a result, this debacle occurred in 1986. All crew members lost their lives, and sadly, American people and suffering and low self-esteem because of this failure. This is a collapse of the Point Pleasant Bridge in 1967. Metal fatigue and the critical eye were due to the London traffic load. As a result, on December 15, 1967, Silver Bridge collapsed under the weight of the rush hour traffic, resulting in the death of the 46 people. This is a crash. This is first the commercial jet. It came from the structure failure, resulting in metal fatigue and in the airplane. As a result, the problem starting emerging and suffering a catastrophe in flight, break, and years entering an airline service, with 3 at the combat lost within 12 months and a high probability accident. This is the failure mechanism and the product design. And this is a bridge. The construction, the bridge is the subject repeatable load. There are some design flaw. The structure will be collapsed each lifetime. The issue to find out the design flaw of the real probability. The solution is live testing and parametric art. And this is my graphic survey study and abstract. First, I will explain of the quantum well and model. I will developing and the transport phenomena, and the first I developing and the time to failure model. And then I will the developing and the accelerated factor based on the system modeling. And then finally I will developing and the accelerated factor is depending on the ratio of the force. Finally, I will carry out and the parameter alter to find out the design fault, and then find the design fault, and I will modify and design the defect. And this is non-interacting and electric moving and constant potential wall. This is the governing equation and the time-dependent loading equation. We apply and the boundary condition, we can find the and some the solution. This is the linear transport phenomena in the mechanical failure, and J is the flux factor, X is the driving force, L is the phenomical transport coefficient. There are several linear transport process. For example, and this is ohmed the laws and the electric conduct, and the J is the current the density, V is the electric field, and L is conductivity. I will give you an example of the linear transport phenomena. This is the solid state diffusion impurity in silicon. It takes place and electron migration induced voiding, build-up of the chlorine ions, trapping and electron and hole. The J is this is the potential function. If I apply and electric fields, the potential function will be distorted. Finally, and we can describe as the junction function is a function of the sine hyperbole and the exponential. This is a junction function of the in silicon, and if I take inverse, we can find the general stress model. The issue, how to define of the general stress model. General stress model is started with linear, M-power stress, and then exponential. And in the medium stress, most of the test is carried out the medium stress range. Time to failure model is simplified as a function of the M-power stress and the temperature. Finally, and we can finally XL factor is the ratio of stress and the temperature difference. This is a power of the multi-photon system. Power can be defined as a product of the effort and the flow. For example, and the translation, effort is a force and the flow is a velocity. Most of stress came from the effort. We can simplify and XL factor is the ratio of the effort and the temperature difference. I will explain how to derive the sample size equation. Product follows the Weibull distribution. Life function is defined as a function of the shape parameter and the characteristic life. If I take the logarithm, we can find the Bx lives. And the issue, how to find of the characteristic life. Characteristic life is can be defined as testing data. Finally, and we can obtain and the Bx life. Bx life is a function of the characteristic life and the function of the chi-square and the logarithmic and the testing data. To derive the sample size equation, there are two approximations, and one is a chi-square approximation, another one is a logarithmic approximation. Computer slavery is 60%, R is less than 4, and the chi-square function is approaching an R plus 1. And the cumulative function is less than 20%, and the logarithmic function approaching X. If I rearranging, and we can find the sample size equation. This is, I will give you as one of the case of study. This is a redesign of the refrigerator with a compressor. This is the compressor with redesigned the crankshaft. There are a lot of the design fault in compressor. We don't know which part is. Compressor lifetime depends on pneumatic part. To find them, it requires a reliable methodology. This is a parameter design schematic. compressor is designed to the increasing pressure from and the low higher. We don't know how to using and the custom using condition and the environment condition. Engineers should be designed each part optimally. Reliable methodology consists of 3 parts. Failure for the return product, failure with art design modification, finally checking and the product achieve the life target. This is a compressor in the vapor compression cycle. This is a vapor compression cycle. It consists of the compressor and the condenser and the coupling tube and the evaporator. This is a schematic diagram of the compressor. Compressor is working in the slide mechanism. This is a damaged product in field. We found a lot of the wear due to the lubrication problem in field. It came from the improper design of the structure to modify and to and the art and the collector. This is a load analysis for life testing. This is a vapor compression cycle, and this is a TS diagram. From the conservation of the mass in coupling tube and from the conservation of the conservation energy balance in the condenser and evaporator, we can determine the mass flow rate, temperature of the evaporator and the condenser. Finally, and the time to failure is depend on the ratio of the pressure difference and the temperature. This is how to calculate the accelerated factor. Accelerated factor depends on the ratio of the pressure and the temperature difference. And for pressure, the worst of the case pressure difference is 1.1. For accelerated testing, we increasing pressure difference is almost 2. Supposing in the lambda is 2, we can calculate accelerated factor is 3.4. For temperature, worst of the case and the dome temperature is 90 Celsius. And for accelerated testing, we increasing and the dome temperature is almost 120. And the accelerated factor due to the temperature, almost 1.5. And total accelerated factor is 4.6. We apply the duties at the cycle. We can search out the design failure. This is how to calculate of the mission cycle. Life target of the domestic compressor is beyond life 10 years. Accelerated factor is 4.6. Total sample size of domestic compressor is 100. Compressor life target is for 10 years, almost 87,000 cycle. There is no problem with the 19,000 cycle. We can guarantee the compressor life target is at the beyond life 10 years. This is the equipment used for the accelerated testing. This is a test jigger. This is a schematic diagram. And then we can proceed the parameter art with the equipment. This is the result of the first parameter art. A compressor locked due to the lubrication at 7 and 10,000 cycle. This is a field photo. This is the result of the first parameter art. By parameter art, we can reproduce the compressor failure in field. And then we check the design of the compressor. We found in 3 the design problem. One is a low lubrication problem, and another one is a low starting RPM, and then the crankshaft and the material problem. As action plan, we modify and the crankshaft, and we changing and the dimension, adding in the new groove, changing in the material and from the FCD 50 and the FCD and the 500. By parameter art, we can collecting and the compressor failure. This is another result of the second parameter art. Crankshaft, the well is found in 19,000 cycle. It came from the interference between the crankshaft and the slash word due to the narrow clearance. This is a new design. This is an old design. We modify clearance from the 0.1 to the 0.5. By parameter art, we can modify design port of the compressor. This is a summary of the parameter art result. There is no problem, 19,000 cycle. First parameter we found in lubrication problem. Ejection plan, we modify and material and changing and some design. In this is the second result, the design of the result of the parameter art. We found in some wear problem on the surface of the crankshaft. In the third art, there is no problem, and 19,000 cycle and 20,000 cycle, and the compressor achieved the life target beyond life 10 years. This is another the case of study. This is the refrigerator. This is a hinge kit system. Hinge kit system consists of several parts. One is a cover, oil damp, and spring, and the housing. There are a lot of design part of the hinge kit system. We don't know which part was. Hinge kit life target depend on the design flow of the part. To find them, it requires a new derived methodology. This is a parameter design of schematic. Hinge kit system is designed to close the door and smoothly. We don't know how to use and the custom use condition and the environment condition. Engineers should be design each part optimally. Light methodology consists of 3 parts: failure analysis for the return product, parameter art, the design modification, finally checking and the life target achieved. This is a damaged product in field. There are a lot of the cracks on the hinge kit housing. It can from the fragile structure. By reproducing a parameter art, we can collect them. This is a load analysis for the X-light testing. This is a hinge kit system, and hinge kit system depends on the door weight. To increase the impact, we added an additional weight on the end of the door weight. By controlling impact, we can carry out the accelerated testing. This is how to calculate accelerated factor. Accelerated factor is depend on the ratio of the impact. For most of the case, impact is 1.1. For accelerated testing, impact is 2.8. And we supposing lambda is 2, accelerated factor is 6.3. We adding some the duty cycle, we can search out a design failure. This is how to calculate of the mission cycle. The life target of the hinge kit system is beyond life 10 years. Accelerated factor is 6.3. Total sample size of the hinge kit system is 6. And the hinge kit system life target for 10 years, almost 36,000 cycle. If there is no problem at 41 mission cycle, we can guarantee the life target is the hinge kit system is beyond life 10 years. This is a equipment used for the X-light testing. This is a test jigger. This is a hinge kit system, and this is a controller. We can proceed the parameter art with the equipment. This is a result of the first parameter art. Hinge kit housing of the hinge kit system collect and 3 and 50,000 cycle. This is a field photo. This is a result of the first parameter art. By parameter art, we can reproduce a design of flow of the hinge kit system. To reinforce of the fragile structure of the hinge kit housing system, we added some rounding in the outside, and we adding in some rounding in the inside. We also give it to the reinforced rib and housing, and give it to the reinforced rib and on decks. This is another result of the first parameter art. We found in the leaked oil lamp. It came from the pneumatic ceiling structure. This is old design. This is new design. By parameter art, we can reproduce design part of the old lamp. This is another. This is the result of the second parameter art. Housing cover of the hinge kit system crack and the 7 and the 9,000 cycle. It came from the material problem. When operating in the hinge kit system, all damp spot and the strut and the hinge cover. Finally, and the hinge cover is but the fracture. As an action plan, we modify and the material from the plastic to the element die casting. By parameter art, we can modify fragile housing and the cover of the hinge kit system. This is a summary of the parameter art result. There is no problem. 41,000 cycle in post art. We found in the fracture of the housing cover, and we found in the leaked oil damp. In second art, we found in the fracture of the housing cover. In third art, there is no problem. 41,000 cycle and 74,000 cycle. Conclusion, this is my paper and submit to the mechanical system and the signal process, and entitled as improving and the life target mechanical system during in transit, and establish on the quantum the transport live stress prototype and sample size. And this paper is explained my background in the live methodology. This is my books and entitled as Design of the Mechanical System based on the statistic. This book explained the experimental and design methodology described and the parameter art for the derived quantity test and the specification. It able to mechanical civil engineer to find the design flow and achieve the right target. And it also suggests of the bright case of study on the mechanical system. Present the CATCHEM method alternative experimental methodology. Thank you. Thank you for your listen to my presentation. Hello.
Yeah, hello. Thank you.
Thank you, Mr. Swango. Is there any questions from audience? Okay, if there are no questions, we will take a short break for refreshment for a short 10 minutes break.
Thank you.
Thank you. Thank you.
Yeah, hello, good afternoon, everyone. Now the speaker session will start, and I will call upon Mr. Suresh Alovihara from University of Paradenia, Sri Lanka, and his talk is on investigations and analysis of earth materials towards the development in some advanced chemical and catalytic uses. Okay, Suresh Alovihara, you can proceed with your presentation.
All right. Okay. Thank you, sir. Are you audible me? Can you hear me?
Yeah, we are hearing you, but you are not visible to us. Can you click on
All right.
share
Okay.
screen?
Okay. Give me a minute. Just a minute. Right. Okay. Can you see my presentation? Can you see my presentation?
Yes, it's visible now. You can proceed.
All right. Okay. Thank you so much. Okay. Good evening, everyone. This is the Catalysis and Chemical Engineering Conference, which will be held in London, United Kingdom, and in online mode too. I am Suresh Alvihar from University of Peradeniya, Sri Lanka. As an invited speech, I'm going to talk about the investigations and analysis of earth materials towards the developments in some advanced chemical and catalytic uses. We will see what about the content of this presentation. Okay, this is the introduction part. In most of occasions, the modern research studies of wastewater treatment, and we are able to find some sort of developments and applications in following materials. As an example, clay materials. The content of most of clays are kaolinite, montmorillonite, and smectite. Those are common clay minerals. And next, the dolomite, then zeolite, activated carbon. Activated carbon is some sort of synthesis of some natural coal or charcoal. And next, the sawdust, rice husk, and plant materials. In modern research activities, those materials are currently being promoted by most of researchers, engineers, and so on. Okay. When considering the applications of those materials, the important properties are the adsorption, which is called as the process that happened on surfaces of some specific solid materials. In generally, the addiction of some molecules from liquid and gaseous compounds onto a surface of some specific solid material. That process is generally known as the adsorption. And also next, the filtration. Filtration is a physical process which can be used to removal of some sort of suspended materials in liquid. In generally, the practice of filtration is performed with the filter medium that required a filter medium and a liquid or gas with suspended solid particles. And also the final process is the absorption, which is known as the entering of some sort of component or substance into a body or volume of another substance. It can either be chemical or physical process. It can be found in both forms. Usually, the atoms, molecules, or ions are entering into a liquid or solid volume from any of existing phase. Okay, in our research, we expected to design a wastewater treatment system with the components of earth materials that namely as different clay types, dolomites, feldspars, river sand, and burnt coconut shell. Based upon the following task, and also the earth materials can do something in the treatment of wastewater, right? Okay, this is the materials and methodology part. Okay, according to the scope and limitation of our research work, the following mentioned earth materials were selected for the manufacturing of the proposed wastewater treatment system. First of all, we selected 3 different types of natural clays, and next selected dolomite variety, and next a selected feldspar variety. Then a selected variety of river sand, and also a variety of burnt coconut shell or activated carbon. Right. According to the objectives of the existing research, the methodology part has been subdivided into following sections. First one is the finding and providing of earth materials. Actually, we expected to find cost-effective materials. That means we have not spent that much of money. Actually, we tried to find all materials from our surrounded environment with least cost. We have done the same, and we found a lot of earth materials undergoing that concept. Okay, then the next part is experimentation of general and essential characteristics of those earth materials and synthesis of some alteration forms of raw materials. That, as an example, the burnt form, right? Okay, experimentation and characterization would be some sort of essential steps in the finding of the properties and characteristics before implementing some sort of applications. Okay, next one is the designing and manufacturing of wastewater treatment system using above earth materials. Okay, that one is an optional. Currently it is being proposed level, and it will be implemented as soon as possible. Okay, those are the following steps that we are going to perform after manufacturing the proposed wastewater treatment system, collecting of different wastewater sample. That means from different categories, as in clinical wastewater, some sort of hospital wastewater, and municipal wastewater, drinking water, and so on. Right, experimentation of the impact of manufactured wastewater treatment system on the qualities of wastewater. So it we can test how it affects on the qualities of different types of wastewater, as like BOD, pH, EC, and so on. Right, actually those steps are not only for us. If someone wish to continue this research up to certain level, they can follow step 4 and step 5. Actually, those are further recommendations. If someone wish to do this kind of research, it is a vital path for you, right? Please keep in mind, right? Okay, these are the results and discussion. In figure number 1, you can see the particle size distribution curves of different types of clays. Okay, I will zoom the figure, and you can see it in clear manner. Okay, here, right. Okay, I will discuss what would be the particle size distribution curve in my next slide. Okay, particle size distribution curve is some sort of graph which is also called as the graduation curve. It is an interpretation of the distribution of the portions of different sizes of particles. Actually, the arrangement of particle in such clay bulk that we are taking into the experiment, okay, or the representative body of the selected soil type. This curve is plotted using the particle diameter, and also the it is taken into the log scale and independent axis, and a corresponding percentage finer on arithmetic scale. Okay, I will come back again for this slide. Okay, in this slide you can see the particle size distribution curves of 3 different types of clay. I have shown those curves in 3 different colors. And also I have given this legend. You can follow the particle size distribution curves while using this legend. Okay. 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 When considering the blue color graph, you can see some sort of small peak or small slope. Okay, that indicates the well sorted or well arranged clay or soil type. That means the presence of soil particles in each and every size in approximately equal amounts or equal percentages. The pink color curve shows some sort of steep slope that indicates poorly grading or poorly arrangement of particles. That means the presence of particles in such clay bulk in uneven distribution. That means asymmetric distribution. Right, okay. The black color curve has been broken in the middle part of that curve. That indicates the absence of some particles of some particular particle sizes in some of points. It is not a constant that it must be here, but it can be any place of the curve. We can find what kind of particles absence in this clay type accordingly with the broken point of that peak. Okay, right. The shape of curve represents some sort of important mechanical characteristics such as porosity, permeability, and some kind of plastic limits and so on. Those are much important in the wastewater treatment application. Actually, the permeability and porosity, right? Okay. Okay. This is the X-ray diffraction or XRD spectrograph of roof tile clay. Okay, we will see what about the description on that. Okay, according to this graph, we can find some sort of highlighted streaks of a 2 theta angle at 14 degrees, 20 degrees, 26 degrees, 45 and 65 degrees. It was indicated the presence of kaolinite as a mineral in a lower amount because of the low intensity of major peaks. Actually, the height of peak represent the intensity. High intensity means high peak. Low intensity means low peak. In this, the further consideration of the chemical formula of kaolinite, it is consisted with the elements of aluminium, silicon, oxygen, and hydrogen. However, we were not able to identify the aluminium in the elemental analysis of this experiment. We will see what are the further discussion on that. Okay. Sorry. In this table, you can see the elemental chemical compositions of earth materials. Okay. We have shortlisted and we have interpreted those chemical compositions in percentage wise according to the earth materials that we use: anthill clay, brick clay, roof tile clay, dolomite, feldspar, burnt coconut shells, and river sand. Okay. Okay. Okay, you can go through this table. These are numerical values we have mentioned. Okay. Right, this is the description on that. According to this elemental chemical compositions of these clays, we can identify the presence of ferrous and the major metallic element with the trace amounts of titanium, barium, zirconium, and potassium. Therefore, the roof tile clay may be applicable in advanced water treatment application based upon the ferrous mineralogy, right? And also, as a special character, we are able to identify more than 75% of ferrous in each and every clay. And also the overall consideration of these clay types, they have not detected any toxic element from any clay type such as the heavy metals or radioactive elements. Therefore, we can confirm that we are able to use those clay types in wastewater treatment applications and human consumption applications, right? Okay, figure 3 shows the FTIR spectroscopy of dolomite. Okay, actually, in the case of in the case of verifications of dolomite and calcite, the FTIR spectroscopy is bit similar, and therefore we are not able to identify or we are not able to distinguish whether it is a dolomite or calcite while using the FTIR spectroscopy without having further experiments, right? Okay. This is scanning electron microscopic image of anthill clay, right? In this figure, I will highlight some important points. In here, you can see some ripple marks on the small soil particles that indicates the presence of kaolinite, montmorillonite, and some clay minerals, right? Okay. Okay, then next one is the scanning electron microscopic images of dolomite. While using the reference of crystal shapes and particular crystal systems, we can confirm the presence of dolomite and both calcite in these dolomitic rocks, right? Okay, according to the obtained results for this research, we found the presence of at least 75% of ferrous as the major element in each and every clay, with some trace metallic elements such as potassium, titanium, calcium, and barium, and also zirconium in rutile clay. Right, kaolinite, montmorillonite, and some other ferrous minerals, namely as muscovite and gluconite in such clay, with quartz as a necessary mineral, as a non-clay, also as a non-clay mineral in those clay types. And also they have found some high amount of calcite in this selected dolomite with a trace amount of potassium, and also they have found some higher potassium and calcium amount presence in this selected feldspar rocks. Okay. In the further comparing of the obtained results with past research outcomes and modifications of materials, it seems that these materials will be much useful in the industrial applications such as catalytic activities, wastewater treatments applications, in the removal of heavy metals due to the adsorption capacity, ion exchanging. Okay. And ion exchanging,
Yeah, hello, Mr. Suresh Aluvihara. You can continue with your presentation. Remaining participants are waiting. Hello, Mr. Suresh Aluvihara. Can you please continue with your presentation?
Okay, wait. Okay, in the consideration of the obtained results, we can find the material will be much useful in such industrial applications such as catalytic activities, wastewater treatment applications, and removal of heavy metals due to the absorption capacity, ion exchanging materials to remove unnecessary ions from wastewater, and in the removal of hardness from wastewater due to the adsorption capacity of dolomite. And this is the conclusion. The particular industrial applications can be shortlisted as follows: the catalytic activities, wastewater treatment applications in the removal of heavy metals, ion exchanging materials to remove unnecessary ions from wastewater, and the removal of hardness from wastewater due to the adsorption capacity of dolomite. Okay, these are the reference that we taken some information into our research works, and also still we are referring in the publication works. Okay. We would like to acknowledge the technical staff members, academic members, and voluntary material providers on behalf of their great support. Actually, we must appreciate their great support right now. Okay, I think this is the end of my presentation. I'm Suresh Alihar from University of Peradeniya, Sri Lanka. I have given my email addresses and telephone number. You are able to contact me at any time if you have any clarification regarding my presentation or any subject matter regarding this one, or any suggestion you can make even later. And now it is end of my presentation. Thank you so much for hearing me. Now it is time to ask your questions if you have any. Thank you so much.
Yeah, thank you, Mr. Suresh Aluvihara. Is there any questions from the audience or participants? There are no any questions. We will continue with our next speaker.
Okay, are there any questions? Still it is time remaining.
Okay, I think there are no questions. Thank you, Mr. Suresh Aluvihara.
Okay, thank you so much. Have a nice day. Good luck.
Okay, now I call upon Miss Rakshita Srinivasan, and she is from University of Southampton. She delivered to talk on her scientific perception on sustainability. Okay, Miss Rakshita Srinivasan.
Yes, am I audible?
Yes, you are audible.
Yeah, so good afternoon, everyone. I'm Rakshita Srinivasan. I'll just start my video for a minute and then we'll go ahead with the presentation.
Okay, thank you.
Yeah. So good afternoon, everyone. Thank you, first of all, for inviting me to this conference. Today, I will be talking about green surfactants and sustainability. Without wasting much time, let's jump right into the presentation. Please allow me a minute to share my presentation. Okay, can you all see my screen?
Yes, it's visible.
Yes.
Yes, you can continue.
Yeah, thank you. So yeah, as I said, today I will be talking about green surfactants and sustainability. And mostly this presentation will be from a chemical engineer's point of view. So we will cover all the basics and then look at the possibilities of green surfactants in the future. So this is our agenda for today. As I said, I will talk about the introduction and then we'll jump into the types, mechanism, and then I will discuss about a small case study, and then we will go on with the future possibilities. So yes, what are surfactants? Well, surfactants are surface active agents that reduce the interfacial tension between two surfaces. As we know, the two surfaces can not only be just liquid and gas, it can be a combination of any of the three states of matter. It could be either solid, liquid, or gas. So yes, and then each surfactant molecule, as you see, has a hydrophilic head, which means it is attracted towards water. That's why it's called water loving. And then we have the hydrophobic tail, which repels itself away from the water, and that's why we call it as water hating. And this, the picture on the right is a surfactant stabilized oil droplet. So this is the arrangement that the surfactant molecules take up in order to become stable. So now let us look at the types of surfactants. And I'm sure we all must be knowing the types. First is the anionic surfactants, where the head groups, as I mentioned earlier, are positive in nature. And these are commonly the soaps that we use every day, and they're alkyl sulfides, and then sulfates. And then it's mostly used in the laundry detergents and dishwashing liquids. So this is most commonly used in our day-to-day activities. And then we have the cationic surfactants, which are made up of quaternary ammonium salts. And these are commonly used with non-ionic surfactants, which we will cover later. And then they are mostly used as textile softeners. They're also used as antistatic additives. Next, we have the non-ionic surfactants, where the head groups do not have any charge. It cannot be either positive or negative, so it doesn't really have any charge. And some of the examples are like alcohols and polyoxyethylene surfactants. Then these are mostly used as wetting agents and also used in food ingredients to enhance the taste. Then finally, we have the amphoteric surfactants, which have both positive and negative head groups. These are mostly betanes and amphoacetates. And since they are quite mild in nature, they're used in the cosmetic industry and have a milder effect on the skin. Now let us look at the mechanism of surfactants. For simplified understanding, I am showing you an example of a typical laundry cleansing mechanism that we come across in our daily laundry activities. So in step one, you see that the fat and oil stain, which is adhered to the substrate, the fabric substrate. So whenever you see a dirt on a fabric, you can consider it as an oil molecule, as I mentioned earlier in the first slide. Usually stains contain some sort of oil, so we can consider that as an oil molecule. So the surfactant is added to the soil fabric containing this oil along with water in the first step. Next, what happens is these surfactant molecules adhere to the fabric in such a way that the hydrophobic parts point towards the soil fabric. And then what happens is this alignment forms a globular structure, thereby reducing the interfacial tension between the fabric and the oil. So as the alignment becomes stronger, it keeps pulling the oil apart from the dirty fabric. Upon mechanical agitation, this soil or dirt is displaced from the fabric to form globules, and some surfactants that are absorbed prevent the redeposition of dirt into the fabric again. And then finally, we have the clean fabric. So yeah, as we see, this is like the mechanism. And yes, So now we'll have a look at what these surfactants do to the environment. Surfactants are usually harmful chemicals, as I mentioned earlier, depending on the surfactant types. They're generally washed out into the water bodies through industrial pipes and then end up in the water bodies by polluting it, as you see in the pictures. This contaminated water isn't just a threat as such, it also goes to the underground and poses threat to the animals and plants which live in the soil. So now, let us look at the UN Sustainable Development Goals. So to address such issues, such as the pollutions that I showed earlier, the UN proposed a list of 17 Sustainable Development Goals in 2015 in order to tackle problems such as humanities, poverty, and other sorts of pollution. And these Sustainable Development Goals are intended to be achieved by 2030, which is barely 7 years from now. So all nations are on the run to achieve at least most of these Sustainable Development Goals. So I have highlighted some of the Sustainable Development Goals, which are closely linked to my topic, and I will show you how these encircled SDGs or Sustainable Development Goals is relatable to my topic. So what is the motivation for me to do this? Well, if you see the picture in this slide, what does it look like? Does anyone want to answer? Okay, I think I will give it away. So the picture here, it looks like a man playing in a snow or something. It looks like any ordinary picture, but sadly it's not. The foam shown here is definitely not pleasant. It is actually the toxic foams accumulated over a lake in India. So the foam was displaced from the surface due to the wind, and that's how it ended up on the streets. So these are not as pleasant as it looks. These are toxic foams. So let us come to the incident. So this is the Bellandur Lake incident, and it is one of Bangalore's environmental disaster, I would say. The foams that you saw earlier represent these toxic foams over the lake, which was displaced onto the streets. So Bellandur Lake is one of the largest lakes in Bangalore, South India, which is where I'm originally from. And since this incident is pretty close to where I live and what I was witnessing, what happened, I decided to take a step forward and bring this issue and how it can be related to surfactant pollution. So in early 2017, Bellandur Lake caught fire due to toxic foam accumulation comprising of methane gas. Excess sewage and industrial effluents led to these anaerobic conditions, which gave rise to this methane gas. And we know that methane gas is highly flammable, which is why it caught fire due to an accidental spark. And this spark caused heavy air pollution, and it burst out into a fire in that particular area and severely affected several communities living around the lake. So the ways in which this incident impacted the community was many people faced breathing problems, not just for that day, they had this prolonged issues, and then they also complained of skin and eye irritation over a period of time. And another evident change which was clearly visible was the rainfall that reduced the following rainy season. The amount of rainfall was drastically reduced, and the following summer season was much warmer than usual. Now we have a couple of results from a year-round water quality assessment which was conducted in Bellandur Lake. So in order to find the foam in the lake, some of the water samples were collecting during consecutive months for a year. The samples were subjected to water quality tests to assess several parameters such as pH, biological oxygen demand, and chemical oxygen demand, and many more parameters. This table shows the result of the water quality test conducted from February 2019 all the way till March 2020. So the BOD and COD levels have surpassed the permissible limit, as you can see. And especially the COD level specifically crossed the permissible limit in the last month on the table. And another thing that we can see is the anionic surfactant concentration. As we know earlier that anionic surfactants are predominantly used in the laundry industry, such as detergents, which I discussed in the first slide. So this study shows that the concentrations of anionic surfactants was increasing. So this evidently proves that this was due to the detergents alone. And then what we have is the surface tension. There was an evident change in the surface tension as well, and it was higher than the surface tension of pure water. And finally, we have the phosphorus content. A known fact about phosphorus is that phosphorus facilitates algal blooms, and algae has the characteristics of foaming. So anionic surfactants along with phosphorus has led to the foaming incident, and this is what we can conclude from this water quality assessment. So what have we learned from this Bellender Lake incident? So this creates a need for sustainable products and processes. And second thing is specifically the public negligence and the lack of responsibility, which led to the health issues and air pollutions and many other issues. And thirdly, we have the policies. If the policies were quite strong, probably this incident wouldn't have even happened. So now let us talk about the need for green surfactants. So as you know that green surfactants are plant derived, and that's why they are eco-friendly. And then they are biodegradable, so which means they cause less harm than the conventional surfactants. And they also generate lesser waste. So some types of green surfactants even perform better than the conventional ones, especially they perform quite similar to the amphoteric ones as I discussed earlier, because they are mild and they don't have much foaming. We also have a misconception that more foaming means more cleansing ability. Unfortunately, that's not the case. The cleansing ability does not really depend on the foaming characteristics. So now we have some types of green surfactants. Firstly, we have the alkyl polyglucosides, which will be for our interest for this presentation. Then we have the lactylates and glutamates. So I will be stressing on the APG, that is the alkyl polyglucosides for this presentation, because they're mostly vegetable derived and they have fatty alcohols. Some example of the APG is the lauryl glucoside and the capryl glucoside. Yes. How is APG made? So APG is synthesized by Fischer's glycosylation reaction, which is the main reaction. It involves the reaction of an alcohol and sugar to give rise to the APG molecule, as you can see. So, and in the presence of catalysts such as sulfuric acid results in the APG. So APG is eco-friendly and biodegradable since its materials are completely plant-derived. So in this slide, we will be having a comparison study of two APG production processes. The one on the left that you can see is a conventional process, which is currently being implemented, although it's not very famous. And then we have the second one is a proposed idea where what improvements can be made to the first step. So I'll walk you through the first process. First is the wheat straw based APG production. So here the raw material is wheat straw. So wheat straw is an agricultural waste. So procuring the raw materials is not very difficult. So the first stage is raw material procurement. Then we have the transportation of the raw material and the pelletization. So since we all know that the wheat straw is having a lot of mass and it occupies a lot of space, that's the reason why it has higher transportation and higher emissions. So, and in step 3, let's go to the pre-processing stage, which involves several steps such as milling, drying, and so on. This process is quite energy and cost intensive due to the number of steps involved, because it is an agricultural waste and it has to be pre-processed completely before it is being transported to the refinery. Step 4 will be the main step, that is the biorefining. As I discussed earlier, it would be the Fischer's glycosylation. And for APG production, the Fischer's glycosylation, the alcohol molecule will be octocosanool, and then the glucose molecule will be the levoglucosan molecule. Then we have this stage, biorefining stage, is considerably having less number of emissions than the other steps for the wheat straw based APG production. And then we have the final stage, that is the storage and distribution, which I'm sure is common for both the processes in general. Then we are introducing an improved step of the wheat straw based APG production, where we use the palm kernel oil and wheat grain as the raw material for producing APG. Here, the palm kernels are much smaller in size, and the wheat grains also, and they do not occupy much space as the wheat straw, which is an agricultural waste. So therefore, the transportation and emissions would be much lower than the previous step. So this is one step that could be changed. And the pre-processing stage is also very simple, as it has only 2 steps. And it does not have a lot of refining that has to be done, because it is already quite pure enough. Then we have the main step, as earlier, biorefining. Here, the difference is the alcohol molecule would be the cetearyl alcohol, and the glucose molecule is the anhydrous D-glucose. And because of the change of the alcohol and glucose molecule, the biorefining stage kind of has a lot of emissions. But overall emissions, if you calculate and compare both the processes, the palm kernel and the wheat grain based production has considerably lesser amount of emissions. So now let us discuss about the system analysis. In the system analysis, let us first cover the long-term sustainability of green surfactants. So this illustration shows the roadmap of surfactants. Firstly, we have the conventional surfactants, which we saw earlier. They are widely used and they are cheaper, but they have a lot of environmental problems, as we saw. And this created a need for green surfactants. And in step 3, among the green surfactants, we discussed that APG is quite popular currently. And then we move on. Within the APG production, we try to introduce a more sustainable production. Even though the difference is not major, the emissions are considerably lowered, which will help us achieve at least one of the sustainable development goals, which I showed you earlier. Now, the developments are being made in finding alternate raw materials which can further reduce the emissions. So to complete the roadmap, we need more investments and more introduction of raw materials and gain popularity in this field. So before introducing anything new, it is crucial that we have to look at the potential barriers. Firstly, the surfactant industry has a very fast changing consumer requirement. And as we know, obtaining very pure raw materials has been a challenging task. And in some of the processes, the pre-processing is quite energy intensive, especially it has higher number of emissions. And due to the lack of popularity, these are priced at a higher range than the conventional surfactants. And some processes have a lot of waste generation, like we saw the first wheat straw based method. And as I said again, emissions caused during this process is quite higher, especially the pre-processing. So again, it comes back to choosing the raw materials carefully. So these are some of the barriers which we need to overcome to introduce like any new product into the market. So society, economy, and policy. So these are the three things that we have to consider, and they are like quite important. And as you can see, the society, economy, and policy are interlinked. So in terms of society, innovative methods, new technology, and processes have a big impact on the society. And as more people invest in new processes, the demand for these products will increase. And this will in turn shed light on new policies to be implemented to meet the current demands. And again, this in turn will affect the economy. As the demand increases, the product costs will be more affordable and more people will be buying it. Additionally, this will also create more jobs for people and impact society in another way. So apart from this being interlinked, it gives us physical and proper mental well-being, and the people, when more green and cleaner processes are adopted, they are at a better state, and it gives an overall sense of happiness. So now in conclusion, as we know that there are several environmental damages caused by conventional surfactants, and that threw light on the need for green surfactants, and we stressed on the APG surfactants and why it was chosen. Since it is already popular, we tried to tweak the current process and introduce a new process, and tried a different type of alcohol and sugar to react in the Fischer's glycosylation reaction. And then we compared completely both the processes and then studied which would be better. We also saw the case study which led to this. And then finally, we went on to the long-term sustainability and then the aspects of society, economy, and policy. So although it's a more generalized presentation, I would like to say that this is like the first step forward in proposing such ideas. And in the future, I'm hoping to do more work on this. At the moment, I won't be able to disclose some of the work being done, but hopefully in the future, we would be able to discuss more. So thank you so much. If there is any question or if anything, I'd be happy to answer. Thank you so much.
Yeah, thank you, Ms. Rakshita.
Yes.
Yeah, is there any questions from audience? Okay, if there are no questions, we will continue with another speaker. I call upon Bokon Alex Akapo, and he is from USC Benin, and his title is Impact of Seasonal Urban Greening Variability on Land Surface Temperature, a case study from Benin, West Africa. Yeah, Mr. Bokon, you can continue with your presentation.
Okay, thank you for giving me opportunity to present my work. My work is the impact of seasonal urban greening variability on land surface temperature. We use a case study from our country, Benin. First, I'm a PhD student in climate change and human habitat in the University of Technology in Nigeria. So for the presentation, we will follow this outline. Benin, the Republic of Benin is a small country in West Africa. So the country area is not too much. And the population is around 30 million inhabitants with around 52% of women. We use French language officially in this country. So the major city in the country are Cotonou first, Porto Novo and Parakou. Our study cities are Porto Novo and Parakou. So we can say that Parakou have only one rainy season, but Porto Novo we have two. It is the same case of the dry season also. So like other countries and cities, we have the problem of climate change that are very much in the cities, in the urban areas. So here we can see that on the urban area the temperature is very high than the rural area because of the vegetation density in the rural area or in the suburban area. So for this concern, we have for our work, PhD work, to examine the influence of green or the vegetation in the urban area on the temperature, land air temperature reduction. So we use as data some monthly satellite images when from what we downloaded or we collected the NDVI data, that are the index of the vegetation. So we use Google Earth Engine source as open source for collecting those data. We use the temperature data that we collect from the National Meteorological Agency in the city, on the two cities in the Republic of Benin. So we know that for the observed data, we have the missing data. In this case, we use the satellite images to download the temperature data by using the codage from Mida et al. So for data analysis, we use Mankindal tests to assess the significance of the trend, and also we use the analysis of variance, the ANOVA, to see whether there is difference or not. And in the case there is a difference, we use the test of the student Neumann and Kills to share to find where this difference can be located. And to finish, we use the sample linear regression to see whether there is the relationship between surface temperature and the vegetation index. RSFOR was used for the statistical analysis. We can notify that we use the data for the both cities and also for the different cities. So as a result, for changing in the urban the vegetation index and the temperature from 2000 to 2020 for 20 years, we see that on the two cities, much effort can be done in terms of the development of the vegetation in cities. So we saw that from 2000 to around 2011, the vegetation has been decreased and start to increase till 2020. It is the same trend we can see in each city take individually. So for the temperature, we know that if the vegetation is increasing, the temperature is decreasing. So this opposition can be seen on the graph. For the seasonal variation of the vegetation index, we saw that there is significant difference between seasons, taking account the both cities and also the cities individually. So these differences can be found for the above city can be found for the season start from January to March, because we have 2 or 4 seasons in Benin generally, but in Parakou the season have uh, are 2 seasons. The seasons are like 2. It is not exclusively, but it is the tendency is 2 seasons. So for the above city, we know we found here that the difference can be found between the season from January to March and April to June, but January, September, and October, December are almost the same. No difference can be found. But if we take Porto Novo, the difference is like the same for the Buff City. But in Parakou, we saw that the 2 first period moment are the same, and the 2 last moment are also the same. The difference can be found between the 2 global season. Now for the relationship between the vegetation and the temperature, for the above city, we can see that this relationship is okay almost, because when the vegetation is increasing, the temperature also is decreasing. So this one is okay. But if we take the cities individually, we can see here that for the period from January to March, we found the positive relationship. It means that when even if the vegetation is increasing, the temperature also is increasing. This is the anomaly that we can find strategy to mitigate or to reduce. It is the same for the city of Parakou, but the period is a bit different. This starts from April to June. So sorry for the conclusion, we can say that the period of January to March show the lower value of the vegetation index, and the positive correlation between the vegetation and the temperature can be found during the dry season. So because of the water currents, so we propose that the smart urban management for water availability can be helpful for assuring the sustainability in the city in case of the temperature reduction. And we propose the research after our work to see the effect of the physiological development of the vegetation and the impact on the temperature reduction, so that we can plan which species we can use in the cities in order to mitigate land temperature reduction. So we wanted to thank the WASCAL, that is West African Science Service on climate change and land use. So they are funding. They fund our work. We also thank our university in Abume Calavi in Benin, also Nigeria where we are enrolled, and the Federal Ministry of Education and Research in Germany that the fund source for WASCAR in Africa. So we want to thank you for your attention. If there is question or recommendation, we can try to give some answer. Thank you.
Yeah, thank you, Mr. Bokan.
Yeah.
Is there any questions from audience and participants?
Okay.
If there are no questions, we will continue with our next speaker. Okay, I call upon Mr. Sai P. Katte, and he is from University of Mumbai, India, and his topic is on repercussion of conflicts caused through chemical derailment and eradication in contemporary existence. Okay, Mr. Sai Katte, you can proceed with your. Yes, you are audible.
Is my screen visible?
Yes, it's visible.
Okay. Before starting this presentation, I am very thankful for giving me this opportunity and to leading this great and scientific scholar conference. That is the 4th edition International Conference Catalysis and Chemical Engineering. My name is Sai Katke. The topic of my discussion is repercussion of conflicts caused through chemical defilement and eradication in contemporary existence. It is a theoretical analysis. Starting with the presentation. Here, this is the index in which I am going to discuss the further topics, that is introduction, consequences and hazards, prevention and discussion, assumptions, and summary. Next, starting with the introduction, my topic is very correlated to the environmental chemistry. So it is a very effective study of chemicals on the air, water, and soil that impacts the environment and human health, as conflicts have also an extreme and environmental life loss, also in very serious global hazards. The hideous amount of pollution it creates in the atmosphere can threaten to the end of the world. There are many understandings of destructions that are correlated with imaginary and actualization actions, but we are really focused on the chemical corresponding issues to analyze and state its certainty of conduct. Human existence has rolled out figure and concern over the next coming ideas to understand and prevent heinous outrages. As our boundaries and limits stay, however, our possibility is far enough to be in existence. So occurrence for chemical eradication are limitless. Through we have to undergo and learn all the faults after any such events. As understanding hazards, toxic gases, weapons, warfare, chemical mixtures and contamination, conversion, and etc. are will be discussing in further slides. Chemical hazards and toxic substances pose a very wide range of health hazards such as irritation, sensitization, and carcinogenicity, and physical hazards such as flammability and corrosion and explosibility. As the very successful management of chemical agent exposure is dependent on early detection. During the time of conflicts, people are more attentive. Suspicious smokes, mist, drops, and flora on building are and strange odor are all warming indicators. As Further, we will be discussing about the outrages that have occurred in the World War I, and we will be discussing. So here we can understand some major chemicals that have been outbursted in this, and many casualties that have been reported. So starting with the tear gas, so it is a light yellow liquid and can cause irritation in eyes, mouth, throat, and lungs. Can lead to have cough, breathing difficulties, in temporary blindness, and etc. Chlorine, so it is a yellow green gas and can cause coughing, vomiting, irritation in eyes, concentration, and can cause rapid death. Phosgene and diphosgenes. So this is a colorless gas and can cause difficulty in breathing, irritations in throat and eyes, having damaging lungs, and can lead to cause death. Mustard gas as one of the important and very useful chemical at the World War I as well as two. So it is a colorless and odorless liquid. And can damage eye, skin, and respiratory tract, can lead to death as well. For the next slide is the consequence and hazards of the study. So, chemical is any material that we, when swallowed or inhaled, can create health conditions. Such chemical can cause and or delay death, and their radiation is very harmful to living world. Radiation can cause DNA in our cells. Some radiation diseases that cause through acute radiation syndromes and cutaneous radiation injuries. Uh, Understanding the radiation harms in the human body, determining the potential dangers. There are some of the points that I would like to mention as well. Uh, Analyzing the human body from head to toe, for example, starting from brain as nerve cells and brain blood arteries can perish, resulting in seizures. Eyes, cataract can be more likely through radiation exposure. Thyroid, when healthy thyroid is exposed, uh, diminished thyroid functioning and long run can cause thyroid cancer. Lungs, breathing in invisible nuclear fallouts can cause lung cancer and can lead to death. Heart, high radiation doses can harm the cell in blood arteries and can limit the supply. Digestive tract damage to sensitive cells in can cause nausea, also blood vomiting and diarrhea. uh, uh, Organs of reproduction, so can have a rapid developing and dividing into cells into ovaries and testes, can cause infertility. Skins that can quickly might be destroyed and can cause resulting in lesion and burns. The lymphatic system as well can have some damage in the immune boosting cell systems. Next is some of the important steps that I would like to mention, that starting from evaluating the health effect of chemical mixtures. Many chemicals without doubt cause human sickness. Well documented in part include arsenic and skin cancer, asbestos and lung cancer, lead to IQ decrement and toxin in chloroacne. Health consequence of individual pollutant may be visible in high exposure situation. The vast majority of people are exposed to chemical mixes of organics and inorganics in lower quantities. Second point is the environmental factor contributing to human diseases. The degree of which environment factor contribute to disease in general is important first question to analyze the role of chemical mixtures in human diseases. So we estimate that environment cause chemical radiation, smokes can cause around 80% of all malignancies, and can have a concern global disease burden on the upcoming generations. Um, as point number 3 is human disease based on current physiological mechanism knowledge. Many environmental influences alter the biochemistry and physiology of the organism without necessarily decreasing life or creating overt sickness. This act can result in irreversible lifelong variation in physical size, IQ, behavior, reproductive ability, and can harm and restrict into developments, as these focus into two important types of sickness, that is abnormality in neurobehavioral functions as well in hormonal disruption due to sex steroids. The fourth point is human disease based on current cellular and molecular mechanism knowledge. Here, the two important conditions, that is neurodegenerative condition, the, where characteristics can be shared in neurodegenerative disorders, and cancer, where interaction between environment, exposure, and genetics can have a very important factor. Next is the fifth point, disease caused by both physiological disruption and cell damages. In affluent countries, cardiovascular diseases is the leading cause of illness and mortality. Next is the point number 6, cellular models of environmentally induced diseases. For example, like chemical mixtures and steroidal hormone function can have steroidal solubility in plasma and consequence delivered through the plasma compartment to target cells and can restrict plasma transport proteins. Each transport proteins have unique ligand binding domain for hormone which it is been associated. Also, male fertility has dropped, and one of the important aspect of the study, as the seventh point here, is study of the health effects of chemical pollutants in food. As we are aware of this, the food we eat is one of the most important determinant of our health. Chemical contamination can also occur and at any stage for food preparation, packaging, transport, and storage. Chemical contaminant can occur as a result of environmental contamination, which has hazardous metal, polychlorinate, biphenyl, and dioxin, as a result of intentional use of chemicals such as pesticides, fertility treatments, and other food contact materials. As chemical contaminants in food is unstudied topic of health studies, it is to be estimated the health burden are required to enhance public health awareness and impart in food borne chemical pollutants. Next is the prevention and discussion of the study, as prevention is the most important efficient method of chemical hazard mitigations, putting in uh, place of efficient chemical management program. Plant may help to decrease or eliminate chemical dangers in food, contaminant, pollutant, and exposure, among other things. So some successful chemical control programs like have been mentioned and can be carried out is to make normal practices from personal, right from awareness to have clean and remove any chemical residue from other touch surfaces, avoid using too much oil or lube on machinery, evaluating all methods on a regular basis of effective and removing chemical allergies with appropriate instrument, and schedule item containing allergies last in the production of cycles. Fourth, I would like to also add use proper storage techniques can also be one of the prevention cause for this exposure. Next is the assumption of our study is that there are, of course, international treaties and prevention for chemical defilement and eradication convention that should initiate and control the proliferation of chemical weapons, contamination, warfare, and can help us to verify disarmament, and they would like to believe the threat which we are occurring can cause naturally occurring outburst, chemical pollution in any damage we create to the environment, and no one can survive without chemic containing our earth. As so far, the next is the summary. So here I would like to add international treaties such as prevention of chemical defilement and eradication convention must control the proliferation of chemical weapons, contamination, warfare that can cause tremendous pollution, radiation, exposure, and effective life. So this will be very helpful according to such treaties. As further more details of this topic are mentioned in the article. Next is the reference that I have used to prepare this presentation and also been added in the article as well. Thank you so much.
Yeah, thank you, Mr. Saikath. Is there any questions from audience and questions? Okay, with no questions, now we will go to our next speaker.
Thank you.
I call upon Karim Tanji, and he's from City Mohammed bin Abdullah University, Morocco. And his talk is on his talk is on novel river sediment, granular CO, nanocomposite for photocatalytic degradation, and COD reduction of crystal violet under visible light. Okay, Mr. Karim Tanji, are you ready for your presentation? From Mr. Karim Tanji. Okay. Okay, I think Karim Tanji is not available now. Okay, Ismail Al Hassan Al Awla, are you ready for your presentation? Can you please let us know? Hello, Ismail Al Hassan.
Yes, I am ready.
Yes, thank you. Okay, now we will invite Mr. Ismail Al Hassan, and he is from Sule Lamido University, Nigeria. And his talk is on effects of synthesis parameters on the crystallization profile and morphological properties of SCaPO5 templated by 1-benzyl 2,3 dimethyl hydroxide. Okay, you can continue with your talk.
Okay. Sorry, I need to. Okay. Share screen. Okay. I don't know, is my screen visible? Not yet.
No, not yet. Can you please click on share screen at the bottom?
I'm doing that. I'm doing that. General. Okay. So It's getting. Maybe you can go to the next presenter if I'm able to fix this out, because it's getting complicated. I'm using a MacBook for the first time, and
Okay, then you want some time to present.
yeah. Give me some.
Okay, okay.
Try to fix this out. Yeah.
Hello, Karim Tanji, are you available? Hello, Karim. Hello, Karim. Hello, Karim Tanji. Are you there? Okay, could you please wait for a few minutes? I will follow up Mr. Karim Tanji. Okay, Karim Tanji is not responding. Hello, Ismail, are you okay to continue, or do you need any time to present your presentation?
Yeah, the challenge is I try to show my.
You can click on share screen button.
Share screen, yeah. When I click on the share screen, advanced files, okay, files, share.
Okay, hello Karim Tanji, are you ready to give your talk? Hello Karim.
Hello.
Yeah, hello Karim. Hello Ismail, can you please mute your audio once? Yes.
Yes, of course. I will
Yes,
my
Karim.
presentation.
Okay, thank you. Please continue.
It's good. No?
Yeah, hello.
I can start.
Mary, are you okay with your presentation? Is there any problem?
You see my presentation?
Yes, it's visible. You can continue.
Okay.
You can go ahead. Okay. All yours.
Hello everyone. My name is Karim Tanji, Doctor of Materials Catalysis and Environmental Process Engineering at University Sidi Mohammed Al Abdullah in Morocco. Firstly, I want to thank the organization committee of this important conference, and I'm very happy to participate in the international conference on catalysis and chemical engineering. Today, I will present my subject, named novel river sediment combined with zinc oxide dot with cobalt nanocomposite for photocatalytic degradation and called prediction of crystal violet and the visible light. As you know today, the economic development and industrial activities, the quantity of effluent has become large day after day, and especially water pollution by the exposure by different industries like textile industry. Since the appearance of this problem, research have tried to find solution, and we have proposed several water treatment methods, such as absorption, and reverse osmosis, but these methods have some inconvenience like complexity and high cost. On the other hand, photocatalysis have attracted much attention due to its high efficiency. It's a clean and eco-friendly method, so the idea is by the treatment of wastewater using this method, we can recycle the water and reuse it like this. We can protect our environment from the impact of these days and also preserve our water resources. The photocatalysis is based on the excitation of a semiconductor like zinc oxide or TU using radiation UV or visible, and then the electron move from the valence band to the conduction band and create a superoxide ion of oxygen and hydroxy radicals, which degrade the organic pollutants. To synthesize the zinc oxide dot with cobalt, we start by combining nitrate cobalt with a nominal molar percentage of 10% to 100 moles of zinc oxide. The synthesized zinc oxide dot with cobalt was impregnated with sediment like a support of this catalyst. The Moroccan river sediment was collected by hand coring with 1.5 meter long core with a diameter of 15 centimeters and a depth varying from 5 centimeters to 15 centimeters. The samples were placed in decontaminated polyethylene container overnight in nitric acid, then dried at 100 degrees for 24 hours. After that, this driver was incorporated in the solution with zinc oxide dot with cobalt to synthesize zinc oxide dot cobalt 10% and 20% supported in this material, which is sediment. Then the nanocomposite obtained was characterized using different analyses, such as X-ray diffraction, infrared spectra, scanning electronic microscopy, and DRS analysis. The X-ray diffraction revealed that the synthesized material samples display that all the diffraction pattern for zinc oxide cobalt catalyst and pixel to the worthy structure without the presence of any peaks due to the other phase were identified associated to the incorporation of cobalt. That means I hear some noise. I don't know why.
Yes, you can continue, please.
That means there is no phase due to the insertion of due to doping cobalt in the zinc oxide matrix. River sediments diffractogram indicates the presence of different phases of muscovite, calcite, hematite, halite, and quartz. The diffractogram of the synthesized zinc oxide doped cobalt supported in the sediment catalyst show the presence of identical peaks of zinc oxide doped cobalt and the river sediment. Concerning the analysis of infrared that indicates the Morocco river sediments present bands due to the presence of hydroxide groups and other bands corresponding to carbon-oxygen groups. Moreover, for the zinc oxide doped cobalt supported on the sediment sample, the zinc oxide bond appear at around 40, 50, and or between 415 and 419 centimeters. And the band located at 490 is the stretching mode of zinc oxide. The band located at 800 is related to metal oxide bond, which is thin. The results of scanning electron microscopy reveal that the river sediment particles are irregular in shape, while zinc oxide doped cobalt with 10% and 20% supported on the sediment material have irregular shape and granular particles were forward. For the UV visible spectrum of zinc oxide doped cobalt supported on the sediment sample was studied to investigate the optical properties and the band gap values of the synthesized material and show the absorption spectrum of zinc oxide doped cobalt with 10% supported in the sediment and zinc oxide doped cobalt with 20% supported in the sediment, and confirms that both composites display an important absorption into the visible light, which could decrease the band gap energy value. The calculated band gap are 2.97 and 2.81 electrovolts for zinc oxide doped cobalt 10% supported in the sediment, and zinc doped cobalt with 20% supported on the sediment respectively. After that, before starting the photocatalysis step, an optimization using box banking design as response surface methodology was carried out. The combined binary effect of the examined parameters is illustrated by 2D counter plots and 3D surface response. The results indicate that the simultaneous increase of zinc oxide doped cobalt percentage and pH value enhance significantly the crystal violet degradation and achieve 100% at the high range level of both factors. We can see that on the figure A and B. The combined effect of zinc oxide percentage and the crystal violet concentration C and D show marked increase of the photodegradation efficiency by rising zinc oxide doped cobalt amount. And all the points of the crystal violet concentration range confirming then that no significant correlation is noticed between the crystal violet concentration and its degradation. Furthermore, it can be shown from figure A and F that a slight rise of crystal violet degradation is noticed by varying simultaneously the crystal violet concentration and pH values. Then, the result of absorption and photocatalytic test, the operating parameters were chosen according to the result obtained from the experimental design. It's found that the best photodegradation it can be when using zinc oxide doped cobalt 20% supported on the sediment river material for the treatment of 20% ppm of crystal violet solution with a pH value equal of 8. The kinetic regression appeared that the crystal violet photodegradation is suitable to the pseudo-fourth order kinetic described by the following equation illustrated in figure 7. The photodegradation rate constant, which equal 0.0014 for the zinc oxide dot cobalt with 20% supported in on the sediment material. And that's confirmed also this material or the photodegradation kinetic with this material more fast compared to other catalysts. The figure 8 presents the results of crystal violet conversion using different scavenger as shown. The degradation of crystal violet using zinc oxide dot cobalt with 20% supported on sediment river material has slightly decreased by the addition of silver nitrate and hasn't changed significantly with the addition of ethylene diamine tetraacid, while the addition of isopropanol and benzoquinone decreased the conversion of crystal violet from 100% to 40 and 30% respectively. Hence, that can be explained that hydroxyl radical and superoxide radicals are the reactive sites responsible for the crystal violet degradation or molecule degradation. Of course, the importance of the stability of any catalyst is interesting. So, for this reason, the stability of our catalyst has been carried out to examine this parameter. Successive cycles of photodegradation of crystal violet degradation were performed using zinc oxide dots cobalt with 20% supported on the sediment material under the optimum conditions obtained from the box banking design, and the results are presented in this figure. As shown, the composite show great stability in the degradation of crystal violet even after 5 cycles, with an important code removal percentage. This affirms the high stability of this catalyst and the high mineralization too. For the conclusion, we can conclude that zinc oxide dot cobalt with 20% non-composite was successfully prepared by Witt's impregnated method to use it as a new photocatalyst with enhanced photocatalysis properties. A degradation yield of 100 of the crystal violet molecule done in 2 hours. Of course, the stability affirmed the high stability of the synthesized composite after 5 cycles with high mineralization, that means high degradation. This work is a collaboration between different institutes, national institutes, National Center of Scientific and Technical Research, City Innovation, and the Higher School of Technology, and our university, Sidi Mohammed bin Abdullah. Thank you for your attention, and I still available for any question related to my presentation.
Thank you very much, Dr. Kerim, for the valuable presentation. Also, congratulations for the quality of your talk.
Thank you.
Okay, thank you for your. Thank you, Mr. Karim.
Thank you.
Ismail, are you? Ismail, are you ready to do your next talk?
I thinking about Salve also takes. Yeah, I am ready now. I can.
Okay,
I can.
yeah.
But
yeah,
he
we are.
I leave from my home.
Wait a minute.
Because man is waiting for me.
Okay, I call upon Ismail Al Hassan
I
Anwar,
think that
and he's from Sule Lamdo University in Nigeria, and his title is on effects of synthesis parameters on crystallization profile and morphological properties of SaPO5 templated by 1-benzyl 2,3-dimethyl dogelium hydroxide. Okay, you can give your talk, Mr. Ismail.
Okay. Yeah, accessibility.
Yeah, Ismail, can you please share your screen?
That is what I'm trying to do.
Okay.
That's what I'm trying to do. When I go to the share screen, it give me some security question desktop. Yeah, sound.
Please click on share screen.
Share system preference. It prop in a kind of security that I need to grant access, which I did. Click change this. Okay, I think. Okay. Hold on. I think it will not be able to record the. Okay. Okay. I think. Can you see my screen now? Share screen. Oh. Now, are you able to see my screen?
Yes, it's visible now. Thank you.
Oh thank God. All right. Good afternoon, everyone. My name is Ismail Al Hassan, and I'm a lecturer in University, University, Kapinhosa in Nigeria, and in chemistry department. My title of the work is going to be on effect of synthesis parameter on crystallization profile and morphological property of SaPO5 templated by 1-benzyl 2,3-dimethyl imidazolium hydroxide. This work is going to be on SaPO5 material. SaPO5 is a zeolite-like material, and it has application mostly in porous. I mean, it has application as a catalyst and ion exchange, and also in the separation. Now, SaPO5 is a zeolite-like, and SaPO5 in particular has AFI framework. It has pores and cages, just the way you see the picture, and it is initiated. I mean, it is originated from ALPO5. The original material is ALPO5. When silicon is inserted in the structure, it becomes a SaPO5. SaPO5 have extra advantage than ALPO5 because it can act as a catalyst due to the presence of Si. So this material, despite that it is a very good material, especially in petrochemical industry and petroleum cracking, but there are a lot of challenges with the way of its synthesis. Most of the challenge comes from the method of synthesis, because these factors, temperature, solvent time, and the templates, always affect the crystallization during the synthesis formation. Now, there are different kind of structure directing agent. Structure directing is actually an organic compound, mostly an tertiary amine, that is used to synthesize this material, which without this organic material, it's usually the synthesis is usually unsuccessful. And unfortunately, this structure directing agent is expensive, That is one. And this compound has preference on a specific structure directing agent. So these are factors that are affecting the synthesis. So now the problem statement for this work is to first of all address the energy consumption during the synthesis of SAPO5 material. For example, usually for the synthesis we require about 180 to 200 degrees Celsius of heating, which takes 2 to 3 days. And also there is not much work on structure directing agent that involve the imidazolium compound. So, and also there is not much study on the effect of synthesis parameters on SAPO5. So this work was aimed to address these gaps. Now, the objective of the work is to synthesize new imidazolium structure directing agent. SDA stands for structure directing agent, containing this benzyl functional group, and use it to synthesize the SAPO5 material, and also to investigate the effect of the synthesis parameters on the crystallization of profile of SAPO5. Now, first of all, before the synthesis of the material, a structure directing agent is synthesized. Now I use benzyl chloride and 1,2-dimethyl imidazole, and I perform reflux at 100 degrees Celsius to obtain the white crystal. Now this white crystal is purified using acetone. Then I exchange it from the chloride to hydroxyl form using an resin of OH type. Now, immediately after the synthesis of the structure directed agent crystal, the ionic salts I subjected to NMR, proton NMR, and the carbon-13 NMR, and also the FTIR, and also carbon hydrogen elemental analysis to confirm the structure, which turns out to be good. You can see the peaks of all the functional group present in the compounds. Now, after that, then we proceed with the synthesis of the SAPO5. First of all, the precursor solution is made from the just prepared solution of imidazolium structure directing agent with phosphoric acid and the water, and also aluminum isopropoxide. They are mixed together and then transfer into the autoclave and then heat at a specific temperature and a specific time. Then after that, the product is calcined and is ready for use as a catalyst. Now, like I said, the effect study was effect of temperature. Now, the different sample were synthesized at a various temperature. For example, I used 2 hours, 4 hours, 8 hours, 10 hours, and 14 hours. All were the AFI crystallic. However, when the temperature, when the time it was increased till 14 hours, some external additional peaks, unusual peak appear, which are confirmed to be for the tridamite dense phase. So, however, the effect of P2O5 and aluminum oxide ratio, that is the phosphoric acid, were also varied into 3 phases. For example, the composition when 2.5 was used, 2.5, that is the smallest amount of phosphoric acid was used, SAPO5 was observed, but the crystal structure shows hexagonal prism, but the particle size is small, and also when higher amount of phosphoric acid is used, then a bigger crystal begin to form and they aggregate to form an integrose. However, when I increase this concentration to 3.5, a totally dense phase of the material is formed. now as evidence from the SEM images and the XRD pics. So now I try to also play around the effect of water content. Now the water content is very essential in the synthesis of SAPO5 because it controls the concentration of the precursors inside and also determine the pH, which the pH is very essential. For example, in the beginning, when I use the water content to be only 135, it produces amorphous phase plus SAPO5. There are peaks related to SAPO5, and also there are but they are not really intense. So it's still we call it semi-crystalline material. Then when I increase the concentration of the water to 180 degrees Celsius, 180 amount, the fuel pace is observed, and there is no additional peak or any amorphous appearance. We can see the formation of the crystal in hexagonal form, which is typical of SAPO5 material. However, when I increase the amount of water to 222 as well as 227, for 225, the size become bigger. This is because the concentration of the phosphoric acid is decreasing. So there are more the concentration, the pH is getting lower and lower. So and the size become bigger. So when I increase the water to 270, there are additional peak which are related to crystallite dense phase. So another dense phase is co-crystallized. Now, the effect of crystallization temperature. Now, in this case, I heat the material at 100 degrees Celsius, and it gives amorphous solid due to the low energy supply. There is no energy supply. The rate of crystallization is very low. However, when I heat at 120 degrees Celsius, now a full crystalline, a semi-crystalline material begin to form, and the particle size is also in nanoscale, 374 nanometer crystals. Now, when this temperature is increased to 150 degrees Celsius, we can see the XRD peak is very nice, with the intense SAPO5 peak without any impurity. However, when further heating is applied to 200 degrees Celsius, a crystalline three-dimensional dense phase is formed. So SAPO5 is a metastable, meaning that it transforms from the less stable material to the more stable, from amorphous to dense phase, which is more stable. Now, because of this study, I try to analyze the basic the basic what do you call formation of this SAPO5 right from the nucleation stage. In the beginning, when in the precursor before heating, the particle size are already in a nanoscale, about 30 nanometer, and that is where the nucleation begin, the polymerization of monomer to polymer, and from secondary building units from primary building unit to secondary building units. Now after that, then it starts forming a larger particles, and the particle size now change from 40 ranges from 40 to 250 nanometer. Then from there, with more heating and prolonged time, it becomes fully SAPO5 crystal, which is the blue color you're seeing, with the embedded structure directing agent in the pore. Now, when we prolong the heating or when we increase the temperature, then the ostwald ripening take place, where the SAPO5 phase is now start transforming into a dense phase, which is no longer a SAPO5 crystal, and then it becomes fully a three-dimensional dense phase, which is microporous material. So, and this brings the end of this study. This study, it helps to, it provides a simple route to understand the effect of different synthesis parameter to the formation of SAPO5 material using imidazolium structure directing agent. Thank you for listening.
Seth Samuel.
Thanks very much, Dr. Ismail, for the valuable presentation.
So I am, if I can, entertain question if you have question.
Is there any questions from audience, participants? If there are no questions, we can continue with our next session, which is a poster session. Okay. Coming to the poster session, the first participant is, I would like to invite Olchikuwo Boneyeshi, and she is from the University of Texas at Arlington, USA. And her title is Direct Partial Oxidation of Methane to Methanol over Nickel Syria Alumina Catalyst. Okay, Olchikuwo, are you ready to give your talk, your presentation?
Yes, thank you.
Yes, thank you.
Can you see my screen? Can you see my screen?
Yes, yes.
Okay, okay.
Wait a minute. Is it your screen or previous guy, that is my, I think, can you please click on your share screen button at the bottom?
I'm sharing the screen already.
Okay. Okay, can you please open your presentation?
Yes, I'm already sharing my screen. Oh, give me 1 minute, sorry. Okay. Okay. Share. All right, yeah.
Yes, now it's visible. Yes, yes, now it's visible.
Okay, okay. Hi, everyone, and thank you for giving me the opportunity to present my work. My presentation is on direct partial oxidation of methane to methanol over nickel oxide serial aluminum catalyst. I'm going to use my thumbnail so that it can be more visible. High energy density liquid fuels are vital for the transportation sector of the world economy. And transportation is something that the world cannot do without. For example, fuels like gasoline, diesel, jet fuels are highly prized and widely used transportation fuels because they have high volumetric energy density. Another alternative source of energy is natural gas, which contains mainly methane. However, transportation and storage of methane poses technological issues, and also methane has low volumetric energy density, which is one of the major challenges for using methane as a transportation fuel. But we can convert methane to other valuable products like methanol, which can also be used as a transportation fuel because methanol is easy to transport and store, and also it has an appreciable level of volumetric energy density. Direct methane to methanol conversion is something that has been explored over the years, mainly the indirect conversion, which involved the conversion of methane to syngas, which is carbon monoxide and hydrogen gas, and then reducing the carbon monoxide in hydrogen to generate methanol. However, this process is energy intensive because it involves a high temperature and high pressure, which is why the direct methane to methanol conversion at lower temperature and lower energy is the desired reaction. However, this process is a little bit complex because it requires optimization of the reaction conditions like the temperature, the pressure, the reactor design, and because it can take different pathways to the reaction, right? So some of the common pathways and other products that can occur during this reaction include carbon dioxide and water, carbon monoxide and water. So to get the desired product, which is methanol, it is important to use like the right catalyst and also optimize the reaction condition. So for our initial study on this, we try to explore different catalysts to find the one that will give us the desired product. And so far, nickel oxide ceria alumina catalysts have been able to give us like the desired products in a large quantity. So for synthesizing our catalyst, we use incipient wetness impregnation method. So first we did co-impregnation of cerium and nickel salts on alumina support, and then we calcined it. So before we did the calcination, we did thermal gravimetric analysis on the pre-catalyst to determine the calcination temperature. And then we determined that to be 455 degrees centigrade. And then after the calcination, we added that to our reactor, which we use a tubular fixed bed reactor for our reaction. And then before we started our reaction, we also did porosity measurements on our catalyst to determine the porosity of our catalyst. Also for the textural analysis, is very important that for our heterogeneous catalysts that they have mesoporous structure, that they are mesoporous. So from the study we did, we observed that the synthesis of our catalyst kind of like reduced the porosity of our catalyst, but that also did not, the effect is not significant enough to affect our reaction. Now for our reaction, we use a tubular fixed bed reaction, and our kickoff temperature was 280 degrees C. And then our methane to oxygen ratio was 1:0.5. And then we also introduced steam during our reaction at 10 ml per hour. Our tear gas was collected during the reaction every 20 minutes, and then we monitored tear gas using gas chromatography with both FID and TCD detectors. So from our gas analysis, we observed that the reaction occurs within the first 30 to 1 hour. Within the first 30 minutes to 1 hour of the reaction. As we can see, there was a gradual decrease in the methane concentration, which indicates that it is being converted. And also there was decrease in our oxygen, and this occurs within the first 30 minutes to 1 hour. And after that, it stabilizes. And then we also noticed the production of CO2, and but when we introduce water, the CO2 production decreases. Now, our reaction was for 18 hours, and after that, we did analysis, or we collected our liquid products, and then we also used gas chromatography with FID detector to analyze our liquid products. And so from our analysis, what we observed was our major product was methanol. And then we also have like traces of ethanol and IPA. And then to further establish a standard for our reaction, we synthesized another catalyst, which is nickel oxide on alumina without the presence of cerium. And then we also did the same, like we run the reaction on that. And what we observed was that during the reaction for just the nickel oxide alumina, we didn't generate any CO2 for the gas section. And this kind of like indicate that the reaction is not taking place because CO2 is one of the byproducts of this reaction. And And then when we did the liquid analysis, we didn't detect any alcohol like the methanol, ethanol, or IPN. So this shows that cerium is very important. It plays an important role in this reaction. And so for our nickel oxide cerium alumina, we calculated the methanol productivity, and our productivity was 17.12, and also our methane conversion was around 79.42%. Now, for our future work, we plan to increase our productivity, even though our productivity is not too low, also is not too high. If we are going to commercialize this process and use it for a large scale production, we plan to optimize our reaction conditions and also explore other catalysts that can get our productivity to the level that we want. And I will also like to acknowledge some of my colleagues and from the CREST lab that supported this work, Dr. Wan and also Hassan. Hassan was from the mechanical engineering department and designed a reactor for this experiment. And thank you. This is the end of my presentations, and I'll be willing to take any questions.
Okay, is there any questions? Okay, I think there is no questions. Okay, I would like to call next participant. Okay, thank you, Ms. Olchko.
Okay.
Okay, thank you so much. Have a nice day. Okay, I would like to call next participant, and she is Mariam Samanian, and she is from Shiraz University, Iran, and his title is Novel Carbon Dioxide Capture based on co-decorated molybdenum disulfide, boosting efficiency of porous 2D material. Okay, Mariam, you can go ahead with your presentation. Hello, Mariam, can you hear me? Hello. Hello, Mariam. Yes, you can share your screen with your presentation. I think your internet is not good. Yes, you are now. Yes, it's now visible. So can you please turn your video? It is
Yes, I start my video.
yes, you can share your screen and start your presentation. Okay, your video is rotated. Can you please rotate it?
Boy,
Hello, Mario. Yeah, can you please unmute your mic? Hello, Mariam. Are you audible? Can you hear me?
Yes.
Yes.
I'm
Your voice is breaking. Can you please?
here. Yeah. Yeah.
Your voice is just getting resound. Yeah. Hello, Mariam. Is there any issue? Hello? Yeah. Hello, guys. Can you wait for some time? I think he had a internet issue. Hello, Mariam. Can you hear me? Yeah, hello, Mariam. We are waiting for your presentation. Yes, you are visible now. Can you please share your screen and continue with your presentation? Hello, Mariam. Yeah, hello, Mariam. Can you please continue with your presentation? We are all waiting for you.
I can start. Do you have
Yeah, hello, Mariam. Can you please continue?
yes? chemical growth of carbon particles on nickel support. Several carbon material have been used. The use of carbon.
Hello, Mariam. Can you please share your screen and view your presentation?
Catalyst for
Your
CH4
screen is not visible.
decomposition offer and durability and also
hello,
high temperature
hello, Mariam.
resistance.
Your screen is not visible. Can you
The
please share
catalyst
your
was
screen?
tested in you don't have my screen. Have my screen.
Yes, please continue by sharing your screen. Yes.
Yeah. Do you have my screen?
Yeah, hello, CEO and Gustavo. Are you ready? Hello, can you please unmute your mic? CEO Mirinda. Yeah, hello, CEO Mirinda. Are you ready? Yes. Hello, Mariam. Can you please continue later? I think your internet is not good. So we will continue with CEO Mirinda.
Yeah.
Okay, CEO Mirinda, can you please share your screen and start your presentation? Hello, CEO Mirinda. Hello, can you hear me? Hello, CEO Mirinda. Hello, Gustavo. Hello, Gustavo Miguel. Are you ready?
Hello. Hello.
Hello. Yes, yes, yes. Yeah, which one? Who will give you first presentation? The CEO or Gustavo?
We'll be presenting together. Kyle will start the screen sharing soon.
Yeah, please continue. CEO or Gustavo, please continue with your presentation. Any one of you. Hello, CEO Mirinda and Gustavo Miguel. Yes, yes. You both want to give presentation at once or one after one another?
Yes, I'm waiting. Kyle, can you start sharing the screen, please?
Yes, yes.
One moment, please.
Yeah, Gustavo is clear. And CEO, can you please unmute your mic and share your screen with your presentation? Yes, we welcome CEO Mirinda and Gustavo Miguel. They are from PUC MG Brazil, and their title is FCAWXCWG process. Okay, you can continue with your presentation. Please go ahead.
All right.
Good afternoon, everybody. My name is Kai, and his name is Gustavo. We study at PUC Minas, and it was a pleasure for us to be invited to present the article that we wrote at this conference. Gustavo and I are mechanical engineer students. We had the opportunity to study a little of welding process, and it's about this that we were going to talk today. We were born in Brazil, so our first language is Portuguese. So in case of doubts related to any word pronunciation, be free to interrupt us. The same you can do if you have any doubt related to the subject presentation. And we hope you like the presentation we have prepared and that is useful. Let's go. About welding, welding can be characterized by the union of two similar or dissimilar materials. The human conquest in the field of metals is dated around 4000 before Christ, and this ability can be compared to fire bending and agriculture. Human ability to manipulate metals without a shadow of doubt became a determinate factor to the sources of human society. In the context of welding, it's related in similar about capacity to join two metal pieces or more. In addition, the Louvre Museum in France was honored to show in its collection one gold pendant dated from around the same time I mentioned before. It was the first weld in the mankind history that is recorded. By coincidence or not, the French Auguste de Meritain was the one that created the first weld by electric arc in 1881, and served the first French patent by welding recorded that time by his students Nicolas and Bernard. For now, that we contextualize a little about the beginning of the world, we can delve into technical issues. About welding ratings, welding can basically be done in two of the most common ways within mechanical engineering: the fusion weld and the pressure welding. And now we're going to show 3 videos about the weld process. They were recorded at Cook inside the mechanical engineering department. The first and the second are about welding pressure, and the third is about fusion welding.
Yeah, hello, CEO Mirinda and Gustavo. Is there any problem? Why did you?
I think it's because of the distance of the connection, the videos got a bit slow and
Okay.
the internet didn't cooperate. But you can show the next one, please.
Okay, if you want to present, you can continue. Gustavo.
Sorry?
If you want to give your presentation, you can go ahead, Gustavo.
Oh yeah, it's going. while it starts to load this. There we go.
Yeah. In the welding fusion process, the phenomenon of 8AZ ridge effect zone emergence is much more critical than the pressure welding process. The 8AZ is basically a distance in the metal base outline that is exposed to resting temperatures of the electrical arc and the all melted addition material. Its length is a function of the rich input that is a critical parameter into melting by mathematics expressed by the relation of tension times electric current divided by weld velocity. The ridge effect zone happens when the temperatures of a welding process reach the values of the less technical treatment undergone by part or 1/3 of the melting of the base material approximately. In case that the part was not treated technically, the 8AZ is very critical because it affects the mechanical properties of the base. Once it is subject to the porosity from gases from welding process or even down change of crystalline microstructures of base materials, depend on the percentage of carbon equivalent of the part. As the melting seeks to unite the base materials without the loss of mechanical properties. One wide ridge effect zone goes directly against the welding definition.
Next slide, please. Well, now talking about the talking about more contextualized of the two processes used. The MIG and MAG process are one of the most used processes in the entire welding part. They are fusion arc welding, and they are good or mostly used because of their versatility. The arc fusion weld is possible because of the electric current, DC in this case. They create an entire circuit, and that starts the ionization, which then will melt the electrode and produce the welding pool. While they are mostly the same, mostly similar process, the MIG and MAG will have some distinction, and that's because of their name. MIG stands for metal inert gas, and that differs because of the inert gas used in the shielding part of it. Normally using some argon or helium gas, this means that electrode will be totally shielded and protected without reacting to the outside environment. And while on the other, MAG on the other hand, stands for metal active gas. And contrary to the MIG process, it uses some reactive gas elements like oxygen or carbon dioxide. That means that the shielded gas itself can react to the base metal or the outside, and that could mean some beneficial properties like deeper penetration or control of spatter. And well, both of them present some similar characteristics like the higher deposition rate and wide range of material thickness, and that means that it's most versatile process on the industry. Now to the next slide, please. Well, the main part of it and the experimental part of this whole article is the process FCAW in comparison to the CWG. Well, first off, both of them are some variation of the aforementioned MIG and MAG process. The FCAW stands for flux covered arc welding, and it can be compared to a MIG process, having the main restriction mainly on the wire electrode itself. It's being filled with a flux material on its core, which guarantees some special characteristics for the welding type necessities. This flux is made of materials that can create some gaseous protection of the melting pool once it's already it already happens. While the other variation, the CWG, which stands for cold wire gas, it's mainly on a double wire welding process. By adding another wire torch, called sometimes the slave torch or the cold wire, it consists in a material rich in active gas protection. So it will be melted in elevated temperatures of the electric arc created by the other electrode or the hot wire. Well, these gases can in turn react with the gas on the protection pool itself and present some more characteristic. And as it says, the comparison between them was made on PUC Minas, was the whole experimental part of this whole article. The parameters itself and its technical distinctions or technical properties are presented in more detail on the article itself, as it's with the entire table comparing the two and its results. But in the resulting conclusion was that the CWG, the cold wire, the cold wire happens to be somewhat more versatile than the FCAW, and for itself being more useful in most situations. That's it for the presentation. Thank you all for the time and attention.
Thank you very much for the opportunity.
Yeah, thank you, Mr. CEO of Mirinda and Gustavo Miguel. Thank you so much for your time. Have a nice day. Is there any questions for CEO and Gustavo? I think there is no questions. Okay, thank you, Mr. Gustavo.
Thank you once again.
Thank you. Hello, Mariam, can you hear me?
Yes.
Hello, Mariam. Mariam Samanian. Can you please continue with your presentation? Okay, Mariam Samanian. And she is from Shiraz University, Iran, and she slightly is novel carbonate capture based on co-decorated molybdenum disulfide boosting efficiency of porous cooling material. Okay, Mariam, can you please continue with your presentation? Hello, can you hear me? Hello, Mariam. Can you please unmute your mic and start your presentation?
Yes.
Yes, yes.
It's my turn.
Yes, you are visible and you are audible.
Okay, I start again.
Yes. Okay.
Okay. Do you have my screen?
Hello, Mariam. Is there any issue of your internet? Can you please continue or please let us know? We will end this conference. You are the last person. Yes, your voice is not audible and your voice is breaking. Hello, Mariam. Your voice is really not good. Your voice is breaking.
Introducing is one and
Hello. Hello, Mariam. Victor here. Can you hear me? I think we have a bad connectivity. Can you try changing your internet connection? Because it's very. No, we cannot able to hear your voice. We cannot able to hear your voice. Your voice is completely breaking. Can you just change your internet connectivity? Hello. Can you try to present from your mobile? Hello. Phone ఉందా?
the different composite also and carbon
Yeah, Mariam, try to connect again and she'll share her presentation in the chat box as she has bad connectivity. Could you please wait for a while? Okay, thank you. Mariam, can you share your screen? You're not able to see your screen. Can you hear me?
Thank you for all.
Hello everyone. Mariam has bad internet connectivity issue, so I shared her poster on behalf of her in the chat box. I think you can view it now and download it. And if you have any questions, you can ping in the chat box. She'll reply. Okay. So, Mariam, can you share your email in the chat box with everyone so that they can write any questions if they have to you? Yes. So she dropped her email. I think with this, we're gonna finish the day 2 of presentations. And I sent a message in the chat box. I request you to send your feedback over email as a testimony, which will help us in the increasing the scope of the conference of 2024. And hope I request everybody to join the 2024 conference as well, which is in the month of March 2024 in Valencia, Spain. Thank you. Have a great day.
Thank you.
You're welcome.